Welcome everyone to day 4 of our completely free AWS Certified Solution Architect Associate 2323 Bootcamp, sponsored by Go Cloud Careers. My name is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, and I'll be your instructor today. In today's AWS Solution Architect Certification course, we're going to be discussing the AWS applications and services. It's an AWS full course tutorial, and it's free AWS certification training covering the entire Solution Architect Associate and some of the Solution Architect Professional training. It's for the SAA-CO3 exam, which replaced the old SAA-CO2 exam. And in this free AWS course, we're going to teach you AWS. And it's an AWS certification online course. So today we're going to cover the AWS applications and services. Many of you joined us last night for the completely free How to Get Your First Cloud Architect Job webinar, and many of you can still join us next Thursday on the completely free How to Get Your First Cloud Architect Job webinar. We'll tell you exactly how to be a world-class cloud architect and how to be upwardly mobile in your career and get your first job regardless of whether you have or do not have experience. Because we're focusing on concepts here, because anybody can read the instruction manual and know what to configure and know how to configure something, but knowing the what and the why, that's what separates the technicians from the engineers and the architects. That's where we're going deeper into the content and letting you download your labs. So please, if you haven't signed up for the labs, sign up for the labs. My team will put how to has a free sample of labs for you to do, as well as a completely free AWS Certified Solution Architect Associate and Professional book, which has even more labs in there. So I want you to get them. I want you to do them, but I want to spend as much time as we can focused on helping you pass the AWS Solutions Architect Associate training, and also give you some knowledge about how the technology works for your cloud architect career, cloud engineer career, or even any type of cloud career that you absolutely desire. So there is that. We're going to talk about the concepts as we go. One thing for Aztec 355, we don't believe in any entry-level positions, and none of our students in our Cloud Architect Career Development Program ever get entry-level positions. We get people getting senior solution architect jobs, and even enterprise architect jobs as their first job. Don't start at the bottom and hope you can learn enough to build your real career. Train for your career. Doctors don't work as nursing assistants to become doctors. They go to medical school. And pilots don't get experience as airplane mechanics to get to their career. Pick the career you want and train for it. That's the way I did it. I didn't start at the bottom. I started at the top, and all of you can too. So kind of keep that in there. And like Refrenzo's Roundtable says, not everybody has the fight to get through. You know, Special Forces has their selection, and they weed out 90% of the people to get to the best at the top. As my old manager, Master Sergeant from the Marine Corps, used to say to me, the cream rises to the top. So those of you who are still here, guess what? Good news. You can continue to learn and learn and learn and rise to the top. And I want you to all rise to the top. So without further ado, well, I'll give you one more thing. I want to know that you're awake, alert, and oriented. So give me a hashtag, AWS Solutions Architect Associate. Because that's what we're here, to make sure that we cover those things, the Solution Architect Associate training. So let's have lots of fun. We'll do 20 minutes as usual. And then after that, we'll do 10 minutes or so as questions. I'm going to try and run till about 4 o'clock today, so we don't have to go on the weekend, and we can all have a free weekend. So let's have a free weekend, but let's really fight in there till the end to make sure you can all win, because I want everybody to have access to as much as we can possibly give them. So we're good. So the hashtag again is AWS Solutions Architect Associate. I see some of you guys are getting it. Love it. I like to know that you are awake. See, I come from medicine where when somebody would follow, we'd say, where are you? What year is it? Who's the president? To make sure you were awake, alert, and oriented. So the hashtag, since I can't see you and speak to you, is my medical version of awake, alert, and oriented, as we would say in medicine, times 3. So we're going to begin with SQS. And I talked briefly about SQS when we talked about the databases. And again, I would recommend using Apache Kafka over SQS because it works in all of your clouds and all of your data centers. But we're on an AWS exam, so we'll talk about AWS SQS. And what is it? It's a message queuing service that provides temporary message storage. We use it to keep messages from being lost. And SQS, or Simple Queue Service, is for transient service. Very simple. I take a message, I pop it in a box called a queue, and I put it into the server when we're ready for it. By using SQS, for example, or Apache Kafka, we can use smaller servers. See, here's the thing. If we've got 1 million messages coming into the server and the server is not strong enough to handle it, they get lost. But if we had a giant server, maybe a $100,000 server or $200,000 server, we'd be able to take in more messages, right? Of course we could. But even a $200,000 server runs out of performance. It's just a matter of when. So if we use a queue, we can make sure, for example, if Taylor Swift tweets, buy this little cat, our music thing, download it right now, all the messages on the way to the database, all the purchases, for example, won't get lost on the way into the server. So that's why we use a queuing system. Of course, I recommend Apache Kafka because when in most cases, because it allows for most clouds, but SQS is the AWS proprietary one. One good thing about SQS is it will facilitate auto scaling because you can look at the number of messages in the message queue. And by doing so, you can tell your system to add capacity. We love this. And what SQS is really designed for is to mitigate the need for the messaging middleware, which you would typically have in a multi-use application. But middleware might be a good thing, or it might be a bad thing. It depends on the application. The key with using SQS over building your own is instead of having to manage servers, you've got this high availability, high scalability thing that helps you modularize your applications. And again, test questions I mentioned earlier, it enables you to segment and decouple your application architectures, which does remove scalability and removes bottlenecks. So graphically speaking, what does this look like? We've got BBC or customer office, or basically you want to buy something off of a website. You can see you go from the web server to the app server, and on the way into the email, on the way to the transaction record, you can use the SQS queue to send it into DynamoDB. We can also fan out some messages, by the way, with SNS and SES, simple email service, which could then send the message directly going to a mail server. We'll get to that later. So SQS has two kinds of queues. I briefly talked about it under the database section, but I want to talk about it a lot more here. It's got standard queues. What's a standard queue? As soon as the messages go in, they go out as soon as they're ready for them. Because the standard queue is in and out, in and out, in and out. It's fast, 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 fast. And that's going to offer the fastest throughput and message delivery. And every message will be delivered at least once, but the messages may be out of order. By comparison, we can set up a FIFO queue. And if any of you guys are used to FIFO accounting from a past life, you'll understand that first in, first out concept. If not, you can look at the FIFO queue as message 1 goes in, message 2 goes in, message 2 goes out, message 3 goes in, message 3 goes out. So there's a first in and first out guarantee, and the message will be processed in the order that they're received. Kind of like when you call a phone and the queuing system says your messages will be processed in the order they were received. Same thing. Same thing. But by doing so, we may increase latency because some messages may be bigger than others. And it's kind of like if you're in a line and there's a big slow person that walks with a cane in front of you in that line, and you've got a bunch of marathon runners behind them, the marathon runners are going to have to wait between the big slow person that's walking with a cane. But first in, first out will guarantee message 1, message 2, message 3. But it will lose speed, as I described in the situation. The last kind of queue that we can set up is something called a dead letter queue. And this term comes from the actual post office. When the post office would get message, they didn't know what to do with it. They'd stick it in a dead letter queue and try and redeliver it later. If a message failure, delivery occurred. Guess what? Same thing over here. We got messages, they don't get delivered, stick them in a dead letter queue and can potentially do something with them later. So messages are sent from the computer to the queue. The message sits in the queue, it gets scheduled for delivery. And if the ultimate destination is busy, it can stay in the queue for up to 2 weeks. Great way to not lose your transactions. And I know I showed this in the database section, but in case you weren't there, SQS is a big component of many of the architectures in AWS. Of course, you could use Apache Kafka, as I said. The sender is going to send a message into the queue, as you can see. The receiver pulls out the message from the queue. And once the receiver takes the message from the queue, the message is drained from the queue, so it won't be there in the future. So when you're going to use SQS to assist with capacity planning so messages are not lost, to optimize your costs so you don't need as big as servers on the receiving end, to handle spikes in the platform so you're not at 100% for 1 minute on your CPU and then 2% for the next 5 minutes and losing messages. So that's really why we're doing it. It's going to help increase write capacity on databases. Now, the next service we're going to talk about is Message Queue. Amazon Message Queue is a fully managed open source message broker service for Apache ActiveMQ or RabbitMQ. Again, you could just use the Apache MQ. You don't have to deal with this, but you're going to manage your servers. Amazon MQ makes it easy to set up message brokers in the cloud, so you can basically migrate messaging and applications without rewriting the code. Enterprise level customers would benefit the most from using Message Queue because they no longer have to re-engineer applications to use SQS and Amazon, because it's something very standard. So if an organization is using something like Apache Cassandra or Apache MQ, they can just use the same one on the cloud. Of course, they can just migrate their server over to the cloud and not have to worry about this and not have any services like this, or they can use this managed service, either or. Amazon Message Queue offers pay-as-you-go pricing, meaning you pay only for the time that the message broker instant runs. However, the storage is billed monthly. AWS calculates the gigabit for each hour and divides it by the number of hours per month, and it results in a gigabits per month with data transfer fees charged separately. That's where all these serverless things can be great or can be terrible. If you don't have a lot of messages, they're going to be much cheaper than managing a virtual machine. But if it's nonstop messages, it might be more expensive than managing your own virtual machine. So this is a thing where analysis needs to occur before you make a decision. It's not that we need FinOps to manage the cost after the fact. The architects need to understand exactly the message type, and then they can architect the cheapest solution. FinOps is great after the fact to try and make things done, but better design it right in the first place than to try and clean up after the fact. So now let's talk about SNS, or Simple Notification Services. Amazon Simple Notification Service is a managed messaging service to deliver message between systems and people. Again, decoupling applications, decouple messages between microservices, for example. And it's used to send SMS, email, and push messages to mobile devices. And it's going to facilitate communication between senders and recipients via this kind of publisher-subscriber model, in which the publisher publishes and the subscribers read the subscriber messages. Kind of like if you signed up for an email list, they publish to the list, and if you're on the list, you receive the message. They can also send push messages as well with this. And SNS can also be used to fan out messages. What do I mean by that? In this particular case, we can have a publisher who sends a message to an SNS topic, and the people could be subscribed to it. Could be a message queue, a Lambda function, an email notification, an HTTP push. Here's an example of the way we could use potentially a message queue or SNS service. Talk a little bit about the SNS platform functionality. It's a high availability platform as long as the cloud's up and it runs across multiple availability zones by default. Cloud goes down, you got nothing, but the cloud's up. This is a pretty high availability system as far as the cloud goes. And whether you're using it to fan out messages to an SQS queue, for example, or a Lambda function, we kind of talked about that. SNS can encrypt your messages immediately to protect them from unauthorized access. Some use cases for SNS messages are application and systems alerts, where SNS can send a message to systems administrators. Hey, sysadmins, your CPUs are at 80%. Do something about it. As I mentioned, it can be used for fan out to send the messages to multiple systems. can send a push message to your phone, like to a realtor out there trying to sell a property. Hey, guess what? I see where you're at located, and I got a new property for you that your customers may like. So it's a nice messaging system. Elastic MapReduce, the next thing. So whenever we're going to take data from one database to another database, we have to normalize it. So I might be in database A as Michael Gibbs in all caps. I might be in another database as Mike Gibbs, all lowercase. I might be in another database, M capitalized, ICHAEL lowercase, and Gibbs, YBBS, all capitalized. And we're going to have to, when we want to try and create data lakes and big data environments and move data from one place to the other, speak the same language. It has to be the same. So it's kind of like, if we're speaking different languages, we're going to have a problem. So anytime we go from one system to another system, we typically need a mapping and reduction function. Now, in reality, in most cases, the people on the big data side write a Python Spark script, and it does it for you. You stick it on a virtual machine, and all in all, that's probably my recommendation if you've got a really big data environment and it really matters. Elastic MapReduce is a pre-made system that's going to simplify this for simpler environments. And it's basically a pre-made map and reduce function to try and normalize your data. But again, if you're going to be multi-cloud, you're going to most likely use a Python Spark script instead of this. And that way, you're going to use the same script on all your clouds. But it's a managed service, which means there's no virtual machines. And Elastic MapReduce is a pre-built system that facilitates big data analysis and processing without you having to configure servers, install applications, or set them up. And Amazon Elastic MapReduce is based on open source tools such as Apache Spark, which is the Spark that I'd be talking about, Apache Hive, Apache ASpace, Apache Flink, Apache Qt, and Presto. And it does offer high performance because it sits on massive servers sitting in the Amazon environment, and there's no management. So it's simple, it's elegant, but it may or may not be enough for what you need. So kind of keep that in the back of your mind. Here we've got information coming, say, out of object storage, which is like a database, into MapReduce, and gets reduced and to another bucket. And as you create a data lake, you're mapping and reducing from lots of different environments. And that's really what that's for. Now, DynamoDB may be a no-no when it comes to multi-cloud environments. And lots of organizations aren't using it for that reason. They're using Apache Cassandra or MongoDB. And it's really based upon the time and the read and write patterns of organizations' traffic. But that's a much deeper architectural concept than you could cover in a certified solution architect, associate, or professional. That's architecture. So because Amazon needed a more standards-based database that people would be happy with, they come up with Apache Keyspaces, which is a fully managed serverless Apache Cassandra environment that allows you to run standard Apache Cassandra type things without worrying about the underlying technology. Keyspace is used to migrate, run, and scale Apache Cassandra workloads. Realistically, the service provision patches and manage the underlying servers, which you don't know about, and it's taken care of for you. And there's two throughput capacity modes, on demand and provision capacity. On demand is when you don't know what your capacity is, and you don't have to specify your table's throughput or capacity because it automatically accommodates. Provision capacity is when you need stable and predictable environments, and you can forecast your application traffic ahead of time. You specify the number of reads and writes per second. And you can increase or decrease as necessary. Again, this is a serverless option of something which you could do managing your own by putting them on virtual machines. There are some benefits of serverless in that you have less to worry about. There are some detractions from serverless in that you have much less control, and it's much easier to guarantee performance when you're not serverless, and you can tune and tweak much more in a non-serverless environment. So it's a trade. Convenience for customization. Up to you. Again, what are the business requirements? That's always going to make the determination. Let's talk with LakeFormation. LakeFormation is a managed service that helps businesses create rapid deployment of data lakes The data lake is a repository that holds large volumes of unprocessed and processed data in the same location. The information is coming from various sources. And then this unprocessed data can be captured quickly in raw format. It's tagged with metadata, which is data about the data to give you information. And then the processed data is assigned tables, fields, and other elements before going to storage. The result is relatively easy, slow, and painless capture speeds. And the reason you're doing this is to create a data lake. Again, this is like going to McDonald's versus having the world's greatest chef make it for you. A big business is going to have their team design a customized data lake. Small business might love the fact that they've got something simple and elegant. Again, from an architectural perspective, what are you trying to achieve? These managed services do not offer you anything close to what you would get if you had a professional team customize it for you, but they're simple and elegant, which means you don't need as many good people on your team with really good skills. So it lowers your employee cost, but it also lowers your capability. So decisions the organization will have to make. The reason we use data lakes is we're basically taking a lot of data and we're popping it into an environment for future use. And then once we've got the data in the data lake, we could apply some machine learning engine to it to try and learn and glean some statistics from the data. And from there, we can look at the data with visualization tools, etc. Whole point of any of these things, data lakes, lake formation, data warehouses, to gain actionable insights to help the business make better business decisions. Remember, businesses don't buy tech because they like it. They buy it for a purpose. And the better information or intelligence the business has, the better decisions they can make, which leads to greater profitability. Let's talk a little bit about Timestream. Timestream is a fully managed auto-scaling, distributed fault-tolerant, cloud-native SQL relational database. This service specializes in storing and query trackable data, the variables that change over time, like time series data. So think user data, Internet of Things, and operational applications. Amazon Timestream is capable of ingesting trillions of events over a time interval from various device sensors to identify time ranges without change. So think big IoT environments. Well, IoT environments like weather sensors, motion cameras, light sensors, those kind of things, health equipment, patient monitors that are sending constant information. That's what this is really perfect for. And Amazon Timestream will identify trends, patterns, and anomalies with the built-in SQL query engine, which provides rapid point and memory store for lower throughput and faster analytical queries through its magnetic store. We're going to get into CloudWatch next, but before we do, it might be worth taking a 5 to 10 minute break to ask some questions if people have them. So let's see if there's any questions for me before we go to the next topic.
Let's see. I don't think we've got any questions so far, but I'm pretty sure we will. Here we go.
So when do we use SQS? We typically use SQS to send messages into a database. We typically use SNS, or Simple Mode Notification Service, basically to route messages, to send messages between microservices, to send an email. So, for example, I upload a file to an S3 bucket and we use SNS to send an email. Your file has been uploaded. Or somebody buys something and we send an SNS message that says, thank you for your order. Or we've got a message coming in, we want to send the message into SQS for a queue and into a Lambda function, so to fan out the messages. Good question there, SBAT. And another thing you'll notice, SBAT, is Amazon will have 10 different versions of the same thing. This in case is not, but they'll have 15 things that are really the same thing. They just new names. Makes it a lot easier for salespeople to say something, I got something special for you. So while we're at it, while we wait for questions, if you haven't subscribed, please subscribe. Please hit the notification bell so you get notified when we do things. And please like the video. It signals the algorithm and lets other people know the work we do for free. And we put a lot of time, effort, and money into doing free content to help the cloud community. So please help us with that. Okay, well, I guess we'll get to CloudWatch. I'm happy to make some progress. We're going to go to 4 o'clock Eastern today, maybe a little bit before that, maybe a little less than that, and that way nobody has to come in on Saturday. So now we're going to talk about CloudWatch. What's CloudWatch? Because they can make CloudWatch look so complicated. It's logging. That's it. It's logging. That's it. So if you've ever looked in a Windows system, your PC, and you noticed all those logs, or you went on a router and you had a syslog server and it was spewing all these messages, BGP neighbor down, AIM interface, gigabit Ethernet 0/0, up, down. That's a syslog message. It's a logging message. You look on your Linux machine and it's all of a sudden, warning, 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 warning. Those kind of things. Log messages. Somebody logs into your house. It logs into the system. You got a log message. Same thing. And that's what CloudWatch does. It's just a monitoring service to monitor your systems. Gives you metrics like CPU, for example. And it can monitor your applications, and you can use built-in metrics and custom metrics, and we'll talk a little bit about that. And visually, what are we talking about with this logging service? It's something like this. It collects, monitors your information to some degree. You can use alerts and act upon them, and then you can analyze the data and kind of figure things out. No different than any other logging that we've been using for the last 3 decades. Now, when you start with CloudWatch built-in metrics, they're very minimal. CPU utilization, disk read-write information like IOPS that's going on, and network utilization. That's not much. CPU, disk, and network. Not much. You're going to get much more on your own personal computer than this. Now, if you needed real logging that's going to give you any kind of information, then you can set up custom metrics. With custom metrics, you could look at memory utilization, which is critical for your servers, API performance, and other metrics that are going to enable you to actually run your technology. CloudWatch has a notification system that's going to notify customers and let them set thresholds. Ding, ding, ding. You've been hacked. Or ding, 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 your CPU is too high. Those kind of things. Chris, can you hear me? Because somebody says they think my media got audited. Okay, Ken says he hears me fine. Okay, that's good. And CloudWatch is available in 2 versions. I mentioned basic monitoring. Basic monitoring is when your data is available every 5 minutes. Every 5-minute data may or may not enable you to catch things. In fact, even every 1-minute data may or may not be enough for you to catch things, because things get smoothed out as they get averaged over time. So detailed monitoring enables you to collect data once a minute, but of course you pay extra for it. And it must be enabled at the virtual machine, otherwise known as EC2 instance. Let's talk about CloudWatch events. Amazon CloudWatch events delivers a near real-time stream of events as they happen. You can set up a rule, like you've been hacked, okay? So as soon as CloudWatch events become aware of a change, you can set up a function like a Lambda function to go do something about it. So get a message, kick off a Lambda function. So you can do that to try and make change. And this, you can create some event-driven architectures, and that's a beautiful use for Lambda functions in AWS, Azure functions in Azure. It's all the same thing, but those little functions are great, tied to a logging event like CloudWatch event. CloudTrail is something different. So if CloudWatch is for logging, CloudTrail is for auditing. So who did what? So remember I talked about authentication, authorization, and accounting. Authentication is who are you? Authorization is what have you done? And accounting is keeping track of what you did. That's what CloudTrail is for, to keep track of things that happen. Lets you you can actually view events that have occurred in the last 90 days. And if you really wanted to go longer than that, you could set up CloudTrail to store your logs into an S3 bucket, object storage bucket, and you can keep them for much longer. So if you're in an environment like healthcare or banking, where you need to see what's been done, CloudTrail is your solution. And there's two types of CloudTrail trails that we can create. We can create a trail that's local to one region, and this will store your CloudWatch logs into a single bucket. That's the default option when you configure that via the CLI or the API. Or you can create a trail that applies to all regions. Now, this is going to give you much more comprehensive logging and auditing information. It provides a record of all events that occur inside of the organization's infrastructure, and this can help you correlate events. This thing happened and this thing happened. Firewall had a log event, okay? This CPU on this thing spiked. This other IAM thing had a failed login. Maybe you're being hacked, those kind of things. As I mentioned, we can set this up where we can take all of our logs coming from different places, virtual machines, EC2 instances, IAM logins, failed logins, what have you. Databases, any kind that you choose to use. And we can store that logs into an object storage bucket and keep it for a long period of time. Next, we're going to talk about AWS Config. AWS Config is a service that enables assessment, auditing, and evaluation of your configurations. It provides an opportunity to see what changes were made and who made those changes. And when a change is made, AWS Config can send an SNS alert to systems administrators. Config provides consistent monitoring of configurations and will check configurations against an organization's policies. If a change was made that violates the organization's policy, an SNS alert, that simple notification service we talked about before, will occur. And it's going to provide a means to assist with change management, meaning somebody makes a change and you break something, Config will let you know what change is made to help you easily revert it, which is fantastic. And it can integrate into CloudTrail so you can actually get notified and also logged, audited, and maintained in the same place. How does it work? A configuration change is made. AWS Config notes the change and records the change in a consistent format somewhere. AWS change will check the change against the organization's policy, and it will notify the systems administrators of any changes that occurred. That notification can become a CloudWatch event, an SNS, or a notification, or another one. So what does config look like? As you can see, a change is made. AWS Config monitors the service, and it can be sent wherever you need it to, a config API, CloudWatch, S3, or anywhere in between. Now let's talk about CloudFront, which is a content delivery network. Many content delivery networks out there, and Amazon uses a bunch of them for themselves. There's Akamai, there's Fastly, there's I'm drawing a blank on the big one that everybody is the one that took down half of India because India was using a single content delivery network. I'm drawing a blank on the name of it right now, but there's lots and lots of them. Oh, Cloudflare, and there's lots and lots of it. So don't make the mistake that took down half of India that used a single content delivery network. Use multiple content delivery networks when it matters, unless it's not important. So when it comes to Amazon, and of course you should use multiple content delivery networks, they've got their own branded one and they call it CloudFront. And it's a very good content delivery network, but even Amazon wouldn't use it as their only one for redundancy purposes. And a content delivery network is two things. It's a network and it's a group of servers that are distributed throughout the world that do caching. And content delivery networks can reduce the inter-regional bandwidth charges that you have to pay for on cloud computing, which can be extensive. and they also reduce the load on the servers, and they can be incredibly helpful with regards to prevention of DDoS mitigations. And here's the reason why. If you send 10 million messages that are identical messages to the server, realistically speaking, and they're all the same messages, then realistically speaking, that if they're all the same message, then the server doesn't have to answer if it's all the same request. Likewise, content delivery network can promote enhanced availability. If the server's down and the information is cached, it's there. But use multiple content delivery networks. I can see, I believe it's Michael in the chat box, which asked, what content delivery network is Amazon using today? So let me cheat. I just did an NS lookup. And Chris, if you want to share that real quick, my window, you can see right now an NS lookup of Amazon.com. And right now they are using Akamai. Last night, you can see they were using CloudFront. I'll do it again and see if they're still using Akamai. Now they're on CloudFront. You can see in a period of 2 minutes, I've hit 2 different content delivery networks, Akamai and CloudFront, because all high availability, high performance systems use more than one. And if you do this on your house, guess what? You may see many other content delivery networks like Fastly. And all of you, anytime you want, from the command prompt on your Mac or your Windows, type nslookup www.amazon.com, and you'll find exactly what content delivery they're doing. Hey, while we're at it, hey, in the chat box, do an nslookup www.amazon.com and tell me what content delivery network you see. Do you see CloudFront? Do you see Akamai? Or do you see something else? Pop that in the chat box. Ken sees Akamai. And you're all going to be in a different place. And of course, these CloudFront servers all sit in the AWS location. Race is getting Frontier. See, they would never use a single content delivery network. So far, we've picked up 3 different ones in the last 2 minutes. So don't architect yourself in a single cloud or a single content delivery network. Amazon wouldn't do it for themselves, and you should not do it for your customers. And depending upon where you are in the world, you're going to also get a different content delivery network and what time of the day it is. That's why it matters. So they're going to really reduce your server load. And it's going to improve your hosting performance, because let's say I've got a picture of Taylor Swift's cat. My wife made me go to a Taylor Swift concert, and Taylor Swift loves cats. So therefore, my wife loves cats. So if there's a Taylor Swift concert, chances are I go to it because my wife tells me that I'm going to it. And let's see where we're actually at. So if it's a photo of Taylor Swift's cat and it's sitting on a web server, and 10,000 people at the same second request the same photo of Taylor Swift's cat, if it's sitting on Akamai Edge, for example, or at CloudFront, the servers don't have to respond. So by doing so, realistically speaking, the load is reduced on those servers, which means instead of needing maybe 10,000 servers to deal with Katy Perry's cat photo, we might get away with 10 servers to deal with Taylor Swift cat photos. My wife makes me go to see Katy Perry concerts, at least she used to as well. So, I go to wherever my wife tells me. I'm much happier that way. So how does the caching work? Well, let me walk you through how a cache and a caching server actually works. Let's do it right now. Here we go. Let's say the client is sitting on the left-hand side of the screen. The client wants to go see that Taylor Swift cat photo. It's a beautiful cat photo, and makes the request. You can see the request goes and hits Amazon CloudFront. Then from CloudFront, it's going to go to the object storage bucket, which is actually housing the photo of Taylor Swift's cat. Then it's sent back to Amazon CloudFront, and then it's sent back to the client. Now, the next person that wants to get that information, as you can see in the bottom, request that photo from Amazon CloudFront, and poof, the photo is sent directly back to the client. It doesn't hit the server. So by not hitting the server, those servers have much, much, much less load, which means cheaper costs and more scalability. So content delivery networks are awesome. Caching, scalability. Oh, by the way, it typically reduces the latency too, because I'm in Florida and I go look for that Taylor Swift cat photo. And then my wife, who's cat obsessed, 5 minutes later goes to look for that Taylor Swift cat photo. She gets it off of the Miami CloudFront location, which is relatively close to me, instead of having to go back to the server, which could be sitting in San Jose, California, for example, or Nashville, Tennessee, or anywhere else in the world. So huge, huge, huge benefit. Now, by comparison, if every request is for different information, caching does not help. So caching is good for frequently accessed information. If every request is looking for something different, the cache actually adds additional latency, so it's not a good system. So you have to know your traffic. Again, architecture is all about business requirements. What are we trying to do? Now, CloudFront integrates with a tremendous number of AWS services, and it is a great content delivery network, and I don't want you to ever think otherwise. I'm just saying 1 is none, 2 is 1, and 3 is greater than 2. And what this really means is, whether your web service is coming from an EC2 instance, meaning a virtual machine with a load balancer, whether it's coming from object storage, CloudFront, or any content delivery network could work with it. People often use CloudFront to front-end static websites that would be stored on S3, but they could be used for dynamic websites that are stored on virtual machines, or they can be used in a combination of both. Here's an example of a combination of both. CloudFront being used with load balancers for and virtual machines for dynamic content, and object storage for static content. Let's talk about some key concepts. There are 3 key concepts to understand with CloudFront. They are essential for you. They are distributions, origins, and cache control. What is the distribution? When you set up CloudFront, you set up a distribution. And the distribution is identified by a really, really, really ugly name. For all of you that looked up, Amazon's content delivery network, you saw this really, really, really ugly name. For example, if I actually look at mine, here's what I see for CloudFront. I see Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net. Nobody's going to remember that. Same thing with Akamai. For Akamai, I get Echo 15316 dot Delta Sierra Charlie Alpha dot AkamaiEdge.net. So you see, when you use one of these content delivery networks, you get some really ugly URL. So how do we map that ugly URL that none of us are ever going to be able to remember to something that we can use? Remember when we talked about Route 53 and we talked about DNS, we talked about creating a CNAME record? So Amazon will have a CNAME record that maps www.amazon.com to Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net. And then all you see as the user is www.amazon.com. So you can keep that ugly CloudFront distribution name, or you can create a CNAME record, which is what every business would do. Now, let's talk about the CloudFront origin. The origin is where your content's coming from. So you set up your distribution, and then you set up your origin. That's you're telling the content delivery network, where's your stuff? S3 bucket, EC2 instances, load balancers, that kind of thing. And the origin is that's where you're going to put your DNS name to. Now let's talk about the cache control. Anytime you stick stuff in a cache, let's say I put my website in this cache, this phone's my cache with a pretty picture of my cat Cindy over it. Like my cat Cindy, she's a sweetheart. But anyway, so let's say I put all this information in the cache. If the information gets in the cache becomes garbage, everybody else is going to receive garbage. So you can clear the cache if you need to. But also let's talk about cache timers. By default, CloudFront caches your data for 24 hours. Now they do that because the longer the cache, the less work on your servers, because the longer the cache will answer versus your servers. Good stuff, right? Okay, now let's think about this. If I change my website 4 times per day and my cache is 24 hours, nobody's going to see the 4 website changes per day if the cache is 24 hours. So I would have to change the cache to every 6 hours, for example. By doing so, the web servers are going to respond more because every time. So we need to set the cache with the interval that our website's changing to make sure we don't put stale information out there. So longer the cache, the better your DDoS protection, the faster your speeds, the reduced data transfer charges, all good things. The problem is the longer your cache, the less frequently your content delivery network will update, and you risk people getting stale data for a long period of time. So how do you set up CloudFront? Very simply. You set up your web servers and you put your content on them. You create your CloudFront distribution. Amazon will create that ugly name that I was talking about, and you either accept the ugly name or create a DNS CNAME record, which points to a better name, to the ugly name, and then AWS will provision and configure all your edge locations. So the way it's going to look something like this. Your data is going to be sitting in a data center, which is otherwise known as an availability zone, which is going to be in 1 or 2 regions, and then your data will be sent to the edge location, which is where your content delivery network is stored. And that's basically how this works. Actually, while we're at it, I'll walk you through the way the user requests work one more time, because people find content delivery networks a bit challenging. Here on the top upper right-hand corner, we've got a user. The user requests the web page www.gocloudcareers.net, and the user hits the edge location. No one that day has hit the edge location looking for www.gocloudcareers.net that day. So the request from the edge location goes to the regional cache, which is then sent to the website, which you can see in the CloudFront origin servers. Then on the way back, the message is sent to the regional cache, which you don't see here. Then it's sent to the edge location. Then it is sent back to the user. Now, the next time the user in the same edge location before the cache times out, the user sends the information directly and says, I want to go to www.gocloudcareers.com. So the user sends the message to CloudFront. CloudFront automatically has it. So it sends the message right back to the user. And by doing so, it eliminated this entire transit time across the internet, across the content delivery network back to the source. It reduced the charges of all this data along the way. And not only did it reduce the charges, it reduced the latency, and it reduced the load on the server. So here's the thing. If you're going to build a high availability, high performance system, you're going to need a content delivery network, and you probably should use multiple ones. A little more, CloudFront, obviously, or any content delivery network will help your performance by doing 2 things. First, it's got those caching servers. And secondly, which I didn't really explain because Amazon doesn't talk about it, but you probably should know. When we actually go and hit this edge location, and from the edge location on the way back to the origin, this is on the Amazon's private network, so it's not the internet. So we're actually getting better enhanced network services plus caching. So it actually performs multiple benefits, because it's the reason that's the content delivery network. It's an actual private network, not just servers. But most people think of only the caching, and that's all they test you on. So kind of keep that in the back of your mind. We get better network performance too. At the time I made this presentation, there were 217 points of presence for CloudFront. They change all the time. It might be more than that. Again, we get better routing efficiency because we got on the AWS backbone versus the public internet. And CloudFront maintains sessions to the actual source. So you don't have to start a new session with the web server for every request. Again, protecting against DDoS and further promoting scalability. Now, you can actually put a web application firewall like WAF on your CloudFront distribution. And if you do that, that's fine. But I still recommend you using 1 or 2 layers of real firewalls, next generation firewalls like those from Cisco, Checkpoint, Fortinet, or Palo Alto Networks that are going to give you real security. But I guess you could use this at the content delivery network location and then still have your good firewalls. That would be fine behind it. And the point of doing that is then you'll get Shield, and Shield does provide some good DDoS protection, so that would make sense there. But don't count on WAF to be a real security firewall for you, unless it's a small business, because it's not adaptive in nature. So we talked about how I can help prevent DDoS attacks. Now, here's the thing. Any content delivery network will not take full or bad HTTP or HTTP requests and send them to the web server. So got 10 million bad requests coming to the server. You got your content delivery network dropped. So you can't, it makes it much harder to do a DDoS attack. Now, also we can use CloudFront or any other content delivery network to enhance SSL or TLS protocols. And CloudFront supports server name identification and other custom certificates, which is very good. Again, it's a great content delivery network. I'm just saying use more than one. Now, we can also set up private content with CloudFront. Often you're using private content, CloudFront to serve with a public website, but there could be member-only websites, and we can use CloudFront for that. Maybe you've got paid subscribers or private applications. And there's 3 ways to do this. We can set up an origin access identity and restrict the object storage bucket to certain individuals, or we can use signed URLs, or we can use signed cookies. So I think now's the spot to pause, see if there's any questions, and then I'll go back to the content. So CloudWatch, Datadog, and Wireshark in the same category? No. CloudWatch is logs. Wireshark is a protocol analyzer that enables you to look at the data that's going through your systems. So they're used for different purposes. Just think logs. Just go to your computer and look for the log files. If you're on a Linux system, they're often in var/var/log. I think they're in var/log on a Mac. I'm not 100% sure. I don't really look at log files these days. I did in my early engineering days, but as an architect, I don't really get to touch the technology. Mildred, what's the difference between config and CloudTrail? CloudTrail is auditing, and it leaves a log. Config notifies you of any time somebody makes a configuration change, so they work together, but they are actually different. Config is about making sure that things actually fit with the organization's policy, and CloudTrail will just log everything. What triggers the CDN update if Chris made a tweak on the homepage? It times out. It's cache control. How long do you have the cache? If the cache is only good for 24 hours, 24 hours later, all systems will be updated as a general rule. What do we mean by log file? Bear with me. Let me see if I can find one to show you. From my system. Let me just type something real quick. Okay, so app file. Maybe try this. I'm looking for a log on my system. I'm not a sysadmin, so. But I can share my screen. So let's see. Present, share screen. I know I'm not Mr. Linux because I'm an architect, not an engineer. But in this environment, Chris, you can see if I went to var/logs because I'm on a Mac. You can see I've got some log files in here. And this is going to tell me everything that's going on with my system. So I should be able to look at certain logs. Let's see if I can do this. I like install log. Maybe that'll tell me what actually was installed over here. There you go. That's a log. And you're going to get these files. The systems are going to generate these files constantly. And if you've got 1,000 servers, you're going to have thousands of these things going on every second. And this is just an example of a log file of just stuff that I actually installed. We don't need to keep looking at it. But you're going to get log files every time your CPU goes up. You're going to get log files on your routers. You're going to get log files on your switches. You're going to get log files everywhere. And what your systems admins and your sysops people are trained to do is to write scripts to look through these logs and be able to find stuff and make things actually work. because you may want to put me on the center screen. Raise the DNS can load balance web traffic. How do we load balance non-web traffic between data centers? BGP. The way we've done it for the last few decades, we use routing. Routing can tell us exactly which way we want to send our traffic. I can create links and share traffic across links. I can use routing to do this kind of stuff all the time. Any others? Okay, if there's not a lot of questions, we'll keep moving. Keep on trucking, as the song went on. All right, so let's talk about Lambda functions. Lambda functions are serverless, meaning there's nothing for you to manage. And every cloud provider has these things, and these things are fantastic. And for the most part, you can use the same code on a Lambda function as you could on an Lambda function. Google has the same thing. They are simple, basic little things that you can do. Basically, you upload the code and it runs. And it typically supports C#, Go, Java, Node.js, Python. And these things are really about automation. Visually speaking, what are we talking about over here? We're talking about you upload your code and you set up a notification, and then as soon as something occurs, Lambda function, and then you pay for it. So if one of your systems administrators uploads a private file to an S3 bucket as public, we can kick off a Lambda function to actually notify the systems administrator. We can kick off another Lambda function to change the permissions on it. So these functions, Azure functions, Lambda functions, are really exceptional. It's one of those great things that we can do on the cloud. The key to remember with these Lambda functions is that they are stateless, meaning there's no memory of what's going on. So once it happens, the function occurs, it is done. So if you want to have 5 different functions in a row, do this, then do this, do this, do this, and then do this, we need to sequence them somehow, and we will talk about how to sequence them soon. But very useful technology, Lambda functions, Azure functions, because we can set up automation to increase the efficiency, which business is about. All of architectures, how do we make the business more profitable? We make it more profitable by increasing revenue and cutting out expenses, which means people. And Lambda functions can automate things. We also cut out technology, which also can make it, but usually about people. And Lambda is about, and all these automation things are about being able to do things automated with less people, which means less expenses. So Lambda can be run in response to events in your VPC. I mentioned a new video. Like if I uploaded a new video for processing, it could send it. And I'll give you an example of something that we can do. Trigger all kinds of things, SNS, SES functions. So let's say I work in a video processing environment. I do actually. And I don't use AWS for this. We use our own GPUs. For us, it's a much better solution. But let's just say I didn't want to do it render things out on our own GPUs. We could upload a video, for example, to an object storage bucket. We could then send our data to a video server to encode the video. We could then send it to Amazon Transcribe to transcribe the video. We have our own transcription service that we use, but we could use this as well. And then we could kick off an email that says your video has been processed. The Lambda function could take the fully optimized video and stick it in another S3 bucket, and the fully that's been transcribed could be sent to video transcription. So by doing so, we can eliminate the middle person going from point A to point B, and that's why people like Lambda functions that automate, which lowers costs. Now, these Lambda functions are pretty useful, right? They are. So what if we wanted to put the Lambda function closer to the user, at least on a web application? We can, and that's called Lambda at Edge. Again, it's still serverless. It works with CloudFront, and it enables us to run Lambda functions at the edge closer to the user. That's your Lambda at Edge. So same Lambda code, same system, but now it's running by CloudFront as opposed to our system. We upload our code. CloudFront can trigger a Lambda function, and Lambda runs the function, and then you pay for it. Here's the key with these Lambda functions. They can get real expensive real fast, but they are also great. So environment where it's being used some of the time, not all the time, beautiful. Environment where things are running boom, 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 boom. Might be cheaper to not use a serverless function and to create your own on a server. Again, what are the business requirements? It always comes down to it. There's no such thing as better, faster, or cheaper technology. There's the ones that solve the customer's problems best. Now, I mentioned to you that these fantastic functions, and they're great, they run, they're done. And there's no way to sequence them on their own because they're stateless. But if we want to, we can. And AWS has something called step functions. And step functions is a scheduling method for your Lambda functions. Still serverless, so there's no servers for you to worry about. And the way they work is you set up, do A, do B, do C, do D, do E, and it can set things up. So how does it work? You define the steps, step 1, step 2. Then you create your individual Lambda functions. Then you configure the workflow in the step functions. And you connect your workflow components to the individual tasks specified in the Lambda functions, and then it's done. You execute the steps. And obviously, as your needs change, you tune them. Nothing in business is static. You design an architecture, and guess what? 2 weeks later, there's a new architecture you need to use, and we do that. So it looks like this, step functions. Step 1, Lambda function. Step 2, Lambda function. Step 3, Lambda function. And at the top, you can see that step function thing. That step function 3, all it's really doing is sequencing or scheduling them. Let's talk about the certificate manager. If you've got a website, right, you probably need an SSL-based certificate. Otherwise, you won't have access to HTTPS. So Amazon provides a way for you to get a certificate manager using their certificate manager. It's a certificate service, and it looks a little bit like this. You request your certificates, and you can put your certificates on your CloudFront distributions, your load balancers, or wherever you need SSL or TLS-based encryption. Now, when you deploy your certificates, you have 2 options with the certificate manager. There are realistically private and public CAs certificates. You can set up a private certificate, and this is for communication inside of your organization. You can issue certificates for users, applications, services, servers, or devices. Now, a private certificate is used internally and cannot be used on the internet and is available for an additional cost. Public certificates, by comparison, you can request from the public environment and are free. Let's talk about a security service. I think I covered it yesterday, but if not, I'm going to just briefly touch it. It's GuardDuty, and that's a service that monitors your accounts. It's going to look at your CloudTrail logs, your DNS logs, your VPC flow logs, which is traffic flowing through Amazon VPC flow logs circa 2023, are the equivalent of Cisco NetFlow circa 2000. Same thing, about 23 years late, but about the same functionality. And GuardDuty is going to be looking through these logs, and it's going to be looking for patterns of behavior associated with compromised systems. And it's going to send you a CloudWatch event if there's a problem to tell you, hey, there's something that you probably should pay attention to. Macy, again, is a fully managed data security and privacy service that uses machine learning and pattern matching to protect your services in AWS. Macy will provide an inventory of your S3 buckets, including unencrypted buckets, publicly accessible buckets, and those that are shared. And Macy will apply some pattern matching and machine learning techniques in order to identify alert you of sensitive data. As I mentioned before, one of the biggest cloud attacks is related to people that make the wrong configuration errors on object storage buckets, and it's easy to configure, but knowing what to configure is the issue. And 99% of certifications, here's how you configure it, but they don't teach you what any of it means. And we got an army of people out there misconfiguring things, causing problems for businesses. Let's talk about another service called Kendra. And this is a fully managed service powered by machine learning that lets users search through structured and unstructured data. Kendra uses natural language processing, a form out of machine learning, to understand the context of a user's query and find relevant answers. Kendra can look at documents, whether it's HTML documents, PowerPoint files, Word documents, plain text documents, and PDF. And it's capable of indexing structured text like frequently asked questions. Documents using Kendra can be used to filter responses as queries. We can set up custom attributes that can be added to documents as well for very specific searches. We can direct our queries towards more relevant results by increasing or decreasing the importance of individual fields in the index. And if we want to add more weight to the importance of a highest reply or something, we can do so to see postings and things, for example, that are hot on forums that are related to our stuff. Next, we'll talk about Kinesis. What is Kinesis? Now we're talking about Kinesis. Kinesis is another proprietary service, which you probably shouldn't use, which you can also replace with Apache Kafka. And organizations use Kafka for streaming data purposes as well, not just queuing. Again, proprietary service probably doesn't belong in multi-cloud. Swap that out for Kafka and use it all on multiple clouds at the same time. But it's an AWS exam, so we're going to talk about AWS proprietary things, and we're going to talk about Kinesis. And Kinesis is a service for collecting, processing, and analyzing streaming data. Kinesis can connect data in real time. We can use Kinesis with video applications, audio applications, logs, clickstream things, like how often people click on a website, IoT devices sending information in. And in a traditional environment, you take your data, you store it, and you analyze it later. With Kinesis or Kafka, we can take our data in and start analyzing it in real time. Now, anytime we get closer to real time, this is digital transformation. Get access to real-time information, make decisions in real time, boosting your business. So whether you choose Kinesis or Kafka, you've got some digital transformation, but you'll have many more flexibilities with Kafka, and you won't be locked in, handcuffed into a single cloud. But that's up to you and your business requirements and the solutions you're architecting. So why do we use Kinesis? It's an ideal when we've got large amounts of streaming data that needs to be moved. Imagine weather sensors all over the globe sending information every minute or two, every 5 minutes. That's a lot of data. We can push in all these data and we can predict things going on weather-wise. So there's that. Fleet of airplanes trying to tell air traffic control where they're going. It's congested up there, believe me. It's very congested up there, and somebody needs to keep those planes from bumping into each other. Now, that's the air traffic control. We got to be real grateful for them getting us safely to our destinations. So we've got 4 Kinesis platforms: Kinesis Video Streams, Kinesis Data Streams, Kinesis Firehose, and Kinesis Data Analytics. And we'll discuss each one. This is more for the certified solution architect professional, but we wanted to hear anyway. We want to make sure you actually have all the tools. Kinesis Data Firehose is a managed service that enables you to load streaming data into data lakes, data stores, and data analytics. Kinesis Data Firehose can capture streaming data and put it in S3, Redshift, and many other services, and it's fully managed, and it will scale to match your throughput with auto-scaling and monitoring. Now, when we're dealing with Kinesis, they base throughput on shards. I didn't make up the term. A shard is a measure of throughput that equals 1 megabit per second, which can be a lot more dealing with text files, and pricing is based upon the number of shards. What'll happen is prior to you use this, you need to determine how much the capacity in shards, and you increase your shards when additional capacity is required. While we're at it, let's talk about Kinesis Data Firehose. We can have up to 10 shards per region per account. We're continuing to talk about it. And if you need more, you can request them from AWS. We can also set up a policy to auto-scale the shards. And we can set up Kinesis Firehose from the management console. Setup is pretty simple. You basically set up the sources and destinations of your data. Obviously, we're capturing streaming data with Kinesis Data Firehose. That streaming data can be sent for storage, i.e. object storage, S3. And we can also analyze the stuff in real time with business analytics tools, Power BI, for example. QuickSight, those kind of things. Visually speaking, here's an example of Kinesis data firehose. We're pulling data from multiple sources. We're then taking it and storing it in object storage, and maybe we use some machine learning or we use something else to actually look and see what we've actually gleaned. Getting into some of the technical nitty-gritty and the terms, should you see them on an exam, with the Kinesis data firehose stream, this is going to be the underlying entity of the Kinesis data firehose. We're also going to have a record, and that's really the data of interest that your data producers are going to be sending to the Kinesis data firehose delivery stream. A record can be as large as 1 megabyte. Now let's talk about Kinesis video streams. Every connected device, such as smart cars, smartphones, security cameras, can actually be sent to Kinesis video streams. Kinesis video streams can then take the incoming data and safely store it, convert it, encrypt it, and set you up for real-time analytics of what's going on in the video. It automatically scales and handles a very large amount of data. And you can use this via artificial intelligence to actually look for certain things in your data. A Kinesis application specifically for video streams. Kinesis video streams really is about ingestion of it, storage of it, and indexing of your video. So you can search through it and actually find things. You can then take these videos that are sent for processing, media processing, machine learning. You know, it enables businesses to look at what's going on streaming data, to help them analyze the data to make better business decisions. It sets up procedures and evaluates incoming data to help you get a better understanding of it. That's what we're really talking about with Kinesis video streams. Taking your data, aggregate it in a single location, and send it off for processing. Let's go to Kinesis data streams. Kinesis data streams, and this again can be done by Apache Kafka, is a great platform to take real-time streaming data. What's kind of cool about this is you can get your data and send it to data analytics applications within 70 milliseconds. So that's 70,000th of a second. It's pretty great. And it can capture gigabytes per second of information from hundreds and thousands of sources. So financial transactions, location tracking, any of these streaming analytics things are fantastic. And all your cloud providers have them. Apache Kafka also has it. It's a great way to get some business intelligence. Streaming data is captured by Kinesis data streams. It's then sent for processing. And after it's processed, now you can start looking at your business intelligence tools. Here, visually speaking, what it looks like, we've got our data stream sent into Amazon Kinesis streams, which is sent into Kinesis, which is then sent for business intelligence tools like Tableau, Power BI, those kind of things. Some key concepts of Kinesis data streams. We've got data producers. They're the people that send the data. And what will happen is we'll have an application that's going to emit a data record. And the data producers get assigned partition keys to the records, and the partition keys will ultimately determine which shard's going to ingest the data record for which data stream. Of course, we're going to have the data consumer, which is the user, distributed Kinesis applications or AWS service for receiving the data from all shards, and stream is dedicated. Most data consumers are retrieving the most recent data in a shard, enabling it for real-time analytics. A producer would produce a consumer, how you're going to use it. That's the way I always like to look at these things. I like to boil things down to the simplest concepts. With regards to a data stream can be a logical grouping of shards. We talked about shards being a measure of throughput. A data stream will retain the data for 24 hours by default, but you can set it up for up to 1 year. Why would we use Kinesis data streams? Large event data collection, real-time data analytics, capturing gaming data, mobile phone data, mobile systems, IoT devices, that kind of thing. And while we're at it, the last thing we'll talk about here is Kinesis Data Analytics. It's a managed service that enables you to transform and analyze streaming data in real time. Kinesis Data Analytics uses built-in Apache Flink to process large amounts of data. Kinesis Streams is auto-scaling, and it'll scale to meet the organization's needs, and the data on Kinesis Streams and data on Kinesis Analytics can actually be analyzed with SQL queries. Now, guess what they have? Now, because a lot of people like me and anybody designing high availability, high performance systems on multi-clouds couldn't use Kinesis and would have to use something better, guess what they now have? Managed streaming for Apache Kafka. So you can set up your own Kafka systems and have complete and total autonomy, or you can set up managed streaming for Apache Kafka. Now that is a fully managed service that enables you to build and run applications and then use Apache Kafka to process your streaming data. So now you're dealing with something which is substantially better. It's more interoperable with other clouds. Of course, you can use this managed service or build your own and use your same service on multiple clouds, which I'd probably end up doing in a lot of my use cases, but you could potentially use serverless if that's what you're looking for. Trade-off. Less work to do, less customization. Depends on your customer. So managed streaming service for Kafka is going to be a fast, scalable, dual-role, fault-tolerant streaming platform that's going to provide a high throughput distributed messaging system and low latency. Because it's distributed, you can partition it. It can be replicated to a log service. It uses a publish subscribe message bus that can be used to build real-time data pipelines, just like Kinesis, just this is less proprietary. Not proprietary at all. It's a managed streaming platform. Apache Kafka enables you to decouple your systems. The source systems would have their data end up in Apache Kafka, while the target systems would have their data, would source their data from Apache Kafka. Decoupling is exactly why we're using these types of messaging services. Apache Kafka provides a very good, high throughput, low latency, fault-tolerant messaging service that can process millions of messages per second, and it can scale with the needs of the organization, and it is standards-based. So standards-based is always a good option. Why don't we see if there's any questions, and if so, I'll answer them, and if not, we will get back to the content. Darius B. How long does CloudFront remember the content? Whatever the cache timeout is that you set. By default, it is 24 hours, but you can make it less or more. What are the major difference between Kinesis data streams and Firehose as far as the use case and what they can do? We actually covered it, but realistically streaming, data Firehose is more about storing your information for processing next time, and data streams is more about real time for the most part. But Kinesis is not my biggest strength. I don't do any environment for the most part where it's single cloud, so Kinesis is something that I could never use. I would always have my people use Apache Kafka for that reason. So I'm not the biggest Kinesis expert because I don't do proprietary anything unless I have no choice. CloudFront and edge locations are not at all the same thing. Remember, CloudFront is the content delivery network. An edge location is a data center that houses the AWS content delivery network. Can I explain horizontal scalability in regards to Apache Kafka? Karen, I can't, but Praveen definitely can. And in class, because I know you're one of our students, we can message Praveen, and he will definitely be able to help you with that one out, because he's a phenomenal big data architect, and that's why I have him come in and teach the big data when we run our programs, because that was his life before we made him a cloud architect, and he's fantastic at it. One of the keys as an architect is to realize your job is to find all the best and smartest people you know and build a team, because one person can't design anything that this big. Architecture is a team sport. So build your context, find the best network architects you can, enterprise architects you can, security architects you can, IAM architects you can, big data architects you can, application architects, and when it comes to any design, know all those people in your organization and get them in the same room. Design the best thing for your customer. It'll be a better design than any one person could ever do. Not only that, your customers don't want to hear that a single person designed it. They want to know that a team did it. I'm going to invest, $100 million into something. I don't want to think that it was all in one person's head. I want to think that a team of people, 20 people with 20 years experience did it, because that way it's 800 years experience versus 20. And that's what I've done as an architect for the last 2.5 decades. Okay, well, we're making great progress. Hopefully we'll be done at 3:30. If not, we'll be done at 4. And you guys are all going to have a wonderful weekend, and we had a highly productive week of a lot of things. Now we're going to talk about AWS Outpost. Now, what is AWS Outpost? It is a server that you get from AWS. So you have the opportunity to buy your own server from Dell, use your own hypervisor and use it. And the use of that server will be far, 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 far cheaper in most cases than paying for your virtual machines on AWS. But if you wanted to put AWS in your data center and you didn't want to have a competent individual that knew how to use virtualization software, you can get this service from AWS. It's a server, and it has virtual machines on it, and you can stick it in your own data center. Why would you do this? Because the data center is fast. The cloud is slow with regards to latency. So your fastest is your data center. Your second fastest is your edge location. Your third fastest is your cloud. So you have your own server and build a beautiful private cloud with Nutanix or OpenStack and connect that to the AWS cloud. Or you can buy these servers from AWS. You may pay 3 or 4 times more than you ever would from Dell to buy the server, but they manage it for you. So you can use the same management console to do it. So Outpost is a fully managed service. They ship you that server, and it's there. And what happens is the stuff is in your VPC. The server is already in your VPC, so you've got much lower latency. Of course, you can just run your own private cloud, which is what I would do. Spend a whole lot less money on your private cloud and manage it yourself. But, these are kind of, it's your choice how you want to do it. So, it's a fully managed service that's going to enable you to use and basically just set up your virtual machines. Next, let's talk about Amazon Comprehend. It's a natural language processing service. It is a natural processing service that uses artificial intelligence to give computers the ability to interpret text and speech in a way similar that humans do. And this way, human language is going to be dissected into pieces so the grammatical structure can be analyzed. The meanings of words can be analyzed by machine learning. From there, we can extract critical elements of the data. There's lots of good language processing engines out there these days. Elastic Transcoder. So Elastic Transcoder is a service that is used to convert video between digital media formats. So you got something raw video, you want to convert it to MPEG-2, MPEG-4, ProRes codecs, those kind of things that people use in video. You can use this cloud service to do it for you, and you'll pay to use the service, and then it will store your thing in object storage. And that way, you can have a version which is best for iPhones, a version which is best for tablets, a version of your video which is best on your PC. Of course, your video editors can just do this all on their PCs, not pay to do this, and then they can just upload it to the cloud, but that means they're going to have good GPUs and good CPUs in their workstations. Guess what? Your video editors are going to need good GPUs and good CPUs to do their job anyway. But this enables people to do less work and let the clouds of systems to do it for you for a fee. You can do large amounts of things, of transcoding. And you just set up a workflow and it does it for you. It's kind of like using Handbrake on your computer to take your video from one to the other, except instead of your computer doing it, you're paying for somebody else's computer to do it. Let's talk about Poly. Poly is another AWS service. And that's a service that takes your text and turns it into semi-lifelike speech. got lots of voices available for you in different countries. So you've been to a website and you got something that says, hello, this is Mike from Go Cloud Careers. Welcome to my website today. I mean, I wouldn't use this, but I like human things. But for people that don't read or don't like to read, or for people that are disabled and can't read, this can be a very good service. It can take your text and translate it to human speech for people. And it doesn't sound quite as robotic as I demonstrated. But some people say it can help you read a document faster. Personally, I can read a lot faster than I can listen, but everybody reads at a different pace. Poly can return your audio in a real-time stream. So for a call center, for example, it can help with certain things. You can use it as an announcer for public transportation. Great use for this kind of thing. It eliminates the need for a person to get on the microphone and do it. And that way you can have up-to-date, consistent information. Got some very specific use cases which are quite good, but you got to use it for the right things. Recognition. So recognition is kind of a cool service that uses machine learning, and it is used to look for stuff in a video. If you're looking for a bad guy or girl that's a criminal, you can look through surveillance video with recognition and search for FAs and actually find it. Very useful for this. If you're trying to analyze an audience to see what their facial expressions are, to see if a speech went well for a politician, you can use this. You can analyze emotional status and tell someone that their message is not working, change their message. It enables a business to look for stuff that doesn't belong. I speak to recruiters all the time, and the recruiter was telling me that he had sent someone on a job interview, and they did the job interview via Zoom, and the person had some kind of a thing called the bong right next to him. And obviously the job interview was canceled because the person had drug paraphernalia in the job interview. So a business can look for this in its marketing to make sure there's no unwanted content in their videos. Or, maybe someone at Amazon is actually using the Google Cloud that works for Amazon, and they're making a video and you see Google Cloud in the background. I'm joking, but these kind of things happen where a business could have its competitor's product featured in something. And recognition is amazing for this. It's a very good service for detecting anomalies inside of a video. It has some extremely good uses. Let's talk about Textract. Amazon Textract is a machine learning service that extracts text from handwriting and data from scanned documents. Textract uses machine learning to process millions of documents, and it uses a combination of APIs, etc. After reading the documents, Textract can extract numbers, handwriting, query responses from tables, and it can automate document workflows as well. Lots of pattern matching text extracting technologies out there. Using Amazon Textract makes it easy for companies and businesses that deal with a lot of documents to automate the process of extracting critical data from scanned documents. Textract is especially useful when it comes to accurately extracting critical business information such as names, mortgage rates, invoices, that kind of thing. Let's talk about translate. I love translation kind of things. I think in Greek half of the time. I think in English the rest of the time. In business, we're constantly dealing with people all over the world. And anytime you can translate one language to another, it's fantastic. Google has a great translation service that's out there, and this is the Amazon translation service. It uses artificial intelligence technology to translate as accurately as possible and as in real time between what you say and people to another languages. And anytime you can enable people to communicate across boundaries, I absolutely love it. Please understand, this is a machine learning environment. If I say close the lights to my American buddies, they have no idea what I'm talking about. If I say close the lights to somebody in Greece, they know to shut them off. If I say to an American person, I'm going to change your lights, they think I'm going to change their light bulbs. If I say that to a Greek person, they think I'm going to beat them up. I don't beat anybody up, but you get the concept. So the point is, when you're using these translation things, they don't always translate accurately because not every word translates the same. So if you're going to use a automated translation function, be prepared to occasionally offend people. So know it ahead of time and make sure that you can smooth things over as they go along. Again, fantastic service, but some things just do not translate across language. Translate uses neural networks that identify and intelligently translate languages that it supports. It's helpful in converting one language audience to another. How does this work? We've got an encoder. The encoder reads through the entire text word by word, processes the meaning of it verbatim, and then uses a neural network to try and decode it. And the decoder uses what it thinks the words means and translates the text. But again, not perfect, but very, very, very good service. The Translate service also has a feature that can automatically detect an input source language, tell the user what language it is from the aid of Amazon Comprehend, another natural language and processing service, to enable multilingual user experience in your application integration. Translate a paper written in English to Greek, for example, is something that can be done all kinds of times. And this is really good for as a rule. Alexa for business. I don't know many businesses that actually use Alexa. I know lots of businesses that use great Cisco unified communication solutions, Zoom, and others. And but if you're going to use Alexa for business, it could be used to improve the usability of a conference room by providing a method of being able to use some semi-intelligent things to get your company's schedules, tasks, and information. By using Amazon Alexa for business, companies can develop Alexa skills catered to their staff or clientele. Alexa for business enables IT to basically centrally manage and deploy Alexa devices for use by users in, say, shared spaces like meeting rooms, private offices, common areas, that sort of thing. It can be put in conference rooms, cuddle spaces to use Alexa type functions. Now, I don't believe in automagic as a rule. Everybody's got something that does things where it does everything for you. And it's got its strengths, but it's also got its failures. But as we grow and grow and grow, artificial intelligence will make artificial automagic kind of things much, much, much better. While we're at it, on the topic, we have Amazon Elastic Beanstalk, which is a service for provisioning, managing, and deploying your applications. And where is this good? Your real cloud architecture people have the background of the network and the data center because the cloud is just a network and a data center. But let's say you've got software developers and they don't really understand networking and data center, but they want to try and deploy stuff on the cloud. This is where Amazon Beanstalk comes in, where you just upload your code and Beanstalk is going to figure out what you need. And it'll set up your virtual machines, your containers, your load balancers, and it's going to automatically deploy it for you based upon your code. It'll provide the necessary tools for web deployment, and it'll deploy them automatically for you. It works with most languages that developers use: Go, Java, .NET, Node.js, PHP, Python, and Ruby. It is kind of interesting that it manages and provisions the environment for you. And then after it's done, you can remanage it or fix all the things that it deployed. Also manages the health of your applications and is integrated with CloudWatch so you get logs of it. I love the concept of these things, but AutoMagic is not necessarily at the level we want it to be yet, but it will be in the future. Here's how it works. We put the user puts their code in, it's Beanstalk, and it automatically deploys things. Here we deployed a 3-tier web app just by uploading the code. So it's kind of nice. Let's talk about Amplify. Amplify is a service for the quick deployment of full-stack web and mobile apps. Full-stack applications are made up of a front end, which is the user interface, and the back end, which refers to the servers, the code, and the databases that make the app work. The developer can quickly create an application without needing to manage the services, including the virtual machine storages and databases. Amplify includes 3 main tools for development and hosting: the Amplify Studio. Amplify Studio is a web browser-based visual development interface. It allows for simplified drag and drop configuration of the application's front end. the Amplify CLI, which allows command line development of the application's backend. The developer can choose from up to 175 other AWS services to build and support their application just by writing a few lines of code. And Amplify hosting, it can update, push newly updated applications to the internet. Code would be retrieved, say, from a Git repository, Amplify Studio, and then deployed on Amazon's CloudFront delivery network to get a website up and running and performing well. We'll deal with App Discovery. App Discovery is a service that helps enterprises migrate on-premises applications to the cloud. The service reveals data about the business case creation and application migration planning. Business case data includes, I'm laughing and I'll tell you why, the cost of operating in the cloud versus off the cloud, the cost of migrating to the cloud, the cost of leaving your current infrastructure, benefits of being in the cloud, and the cost of doing so. Look, if you've got a fox guarding your chickens, it's not a good situation. App Discovery is the person that's trying to sell you stuff, telling you how much money you're going to save by them. It does not understand the CEO's business needs. It does not understand the organization's customers. So it's helping you do an architecture business case without understanding what you need. So it's a tool. Do with it with you with. You've been warned. All tools are good. They're great and helpful. It's using the right tool. So my brother tells me this is used to hammer nails in. I'm not going to use it to, he uses a screwdriver for a different person, so use the right tool for the right job. No technology is ever going to be able to find business needs and actually do something. And that's why architecture is protected from AI. Whereas engineering tends not to be. In theory, App Discovery is going to make migrations easier by allowing enterprises to make better business decisions. Here, I'm trying to sell you something. Here's the decision, come to my cloud. And what it will do, which is quite good, is it will collect information like your server CPU, your disk space, performance, network utilization, and that's actually good. And some of that captured data can actually be used for analysis. So it's a tool that you use along with your human judgment and things like that. App Discovery used to collect detailed information about the data center. It's going to give you something. You're going to need to collect a lot more information. Well, you're going to need to look at your networks, your routers, your switches, your Cisco flow logs if you're using Cisco things, your servers themselves. You're going to be looking at all these kinds of things. You know what? Let's pause here because we're really running through some of these proprietary services very quickly. See if we can see if there's any questions. If there's not, in about 30 seconds, we'll, okay, Microsoft GPT-4 translation. It is, Microsoft ChatGPT is and future things are actually the future. And there may be other models, but ChatGPT in its beta 4 is beyond anything else that's out there by a far, 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 far majority. And with that $10 billion that Microsoft just invested into it, it'll be life-changing. It'll make things like AWS Code Whisperer look like a dinosaur, and it's just coming out. And, you know, it's going to really give Microsoft, who basically is the king, queen, and everywhere in between of enterprise computing, a huge competitive advantage in the market. At least I think so. How do you create a Kubernetes cluster in AWS? Well, there's two ways you can do it, and we're going to get to some of it. Option one, create the same Kubernetes cluster in the identical way you did in your data center and spread that across multiple data centers or multiple clouds. same way as before. Or you can use the Amazon managed Kubernetes service, which we'll talk about later. But if you do that, and the Amazon cloud goes down, you got nothing. Something my grandma would have called bupkis, and I don't like that. So I'd be having my teams, if it really mattered and I was in 3 clouds, set up my own Kubernetes cluster the same way they did it since 2014. And forget about all the managed services. And you can read how to do that on the Kubernetes webpage. You could look up the Red Hat OpenShift because it's the same way. You can look it up on the VMware page. The same way they've created Kubernetes clusters since 2014 is exactly the same way I would have my people do it, because I could use the cluster across multiple clouds. Any others, Chris? Okay. What is the difference between a Kafka and Apache Beam? I'm not completely sure. The things that I've worked with have used Apache Kafka, and that's not I'm not a big data architect, so I don't want to give you more information, but I know they can both be used for streaming data. Any others? Okay, well, I want to know that you're still awake, alert, and oriented ×3, times person, place, and time. And since I can't ask you questions like I would in my old-fashioned medical days, if you can give me a hashtag AWS Certified Solution Architect Associate, I know you're awake, alert, and oriented. Eva Dykey with the Blue Wrench, I am so thrilled to see you here. While you're at it, if you go to our website, Eva Dykey has helped create some wonderful interview question and answer blogs. She wrote a beautiful blog on edge computing. I encourage you to go view it. She's fantastic, and she's absolutely wonderful to collaborate with. Leo, thank you so much. Tyrone, thank you so much. So again, one more time, hashtag AWS Solutions Architect Associate. If you have not liked, please like this video, subscribe to the channel. If you have not registered for next week's How to Get Your First Cloud Job, my team after these hashtags will pop it in the box for you. And make sure, if you have just joined us, that you get your completely free, How to Get a completely free AWS Certified Solution Architect Associate and Professional ebook. And also do the labs, which you can download. They'll be there. I know you guys are awake. I'm feeling great. I love that. Excellent, excellent, excellent. And I'm seeing names from all over the world. I love that. What is an API gateway and when is it used? It's kind of used like a load balancer to route between microservices. So instead of an application load balancer, it's an API gateway. It's a little different, but it basically works on that same concept. Okay, fantastic. You guys are all awake. Loving that. Loving that, loving that, loving that. So we could talk about AWS AppFlow, which is a bidirectional service that moves and synchronizes data between third-party applications. So it's a software as a service thing. And it can take your information, say, between Salesforce and Slack, and you don't have to write code because it does it for you. It's pretty convenient. All that's needed is to capture data transfer requirements from AppFlow, and it'll move stuff back and forth for you. By aggregating data from multiple sources, companies can make better observations, generate better hypotheses, and draw conclusions based upon the information. Realistically speaking, if you're a business, you need to know what your customer is worth to you. So they know how to spend how much money on advertising, marketing expenses, how to reach the person. And the more information a business has, the better actually decisions they can actually make. So kind of keep that in the back of your mind. AppFlow can improve the business's operational efficiency by collecting things, information, processing and delivering and automating workflows, reducing manual work errors, and reducing the overall cost of doing business. This is automation. The more automation we use, the cheaper a business's costs are because the less people they need. So you can use it to integrate applications, to transfer data at massive scale, and it can help automate data security because it can look at a lot of things. Let's talk about AppSync. It's another service, which is a relatively simple solution that enables multiple applications to be connected and synchronized with data from multiple sources. So that can be databases, Lambda functions, OpenSearch. AppSync can automatically manage and update the data between web and mobile applications and provides real-time updates of the data for offline users as soon as they connect. AppSync again uses that same publisher and subscriber model method to push and pull data from multiple sources. And realistically speaking, a template is created on which data is pulled from the sources and in what form. AppSync is a simple solution to basically help you pull your data. Jeffrey in the Philippines, so thrilled to have you here. I'm going to scream a practitioner, and I've been meaning to take a trip to the Philippines at some point in my life. Welcome. Let's talk about Cloud9. Cloud9 is a cloud-based integrated development environment, which is software that pulls together common tools that are used to build applications under a single graphical user interface. It provides support to over 40 programming languages and helps developers with an environment to build, run, and test and debug software releases. It actually offers the ability to develop, deploy, and debug applications in a browser without even installing the development environment. This integrated development environment helps save time when deploying new applications, as the required tools don't need to be configured separately. And people don't need to learn how to use these tools as well. The Cloud9 also identifies bugs in real time, highlights syntax, and developers do not have to switch between multiple tools. Again, one tool, simplicity, simpler, faster, cheaper. And that's what we're getting to. So it enables your developers to be organized and solve workflow problems. CloudFormation, another product to be completely tossed in the trash. CloudFormation is infrastructure as code. And guess what? There is a replacement for this that works on every single cloud, Nutanix, OpenStack, AWS, Azure, Google, called Terraform. Organizations of matter should be using Terraform, and that way they are not handcuffed to anybody. But we're going to talk about the proprietary AWS infrastructure as code service called CloudFormation. Realistically speaking, it is impractical to configure things by clicking a bunch of buttons in the management console. You can hire a bunch of cloud admins to go do that job, or you can hire one DevOps engineer who can write infrastructure as code, replace 15 or 20 cloud admins, and do it all by writing a script and deploying it all. So that's the migration for DevOps engineers. They're not architects, they don't touch, and they're a completely different job, but that's why DevOps engineering is there, to basically remove all those people by automating, again, reducing the operational costs of doing things. So DevOps engineer writes a CloudFormation script or a Terraform script. Terraform works on everything, CloudFormation only AWS. They then use that script and they can provision the entire cloud in minutes. It's basically a simple text file, boom, deploys everything. It is really, really cool. So if you're an architect like me and you don't touch the tech, because architects don't touch the tech, and you design something, and then you see this DevOps engineer bring it to life, it is really cool. So whether it's a DevOps script, whether it's a Terraform script or a CloudFormation script, realistically speaking, it works like this. The code is uploaded, at least for CloudFormation, into an S3 bucket. You launch the script, and poof, all the stuff is magically deployed based upon the code. It is really cool. Want to generate 1,000 virtual routers to test routing software? Write a Terraform script or a CloudFormation script, You got 1,000 virtual machines running a bird routing daemon, for example, and poof, you can test it. It is the coolest thing, infrastructure as code. But why lock yourself into proprietary solutions when you've got a standards-based solution? So, the CloudFormation templates are available in a multitude of options. You can write it from scratch in either JSON or YAML format. YAML format, you'll know typically from Kubernetes. The code can be stored locally or on your NS3 bucket, and you can basically use that code via like the CLI or poof, it's deployed, and wow, it's really great. Your whole thing is deployed, and it is really great. One of the things that makes the cloud. Now, it can be a private cloud like a Nutanix cloud or an OpenStack cloud, or a public cloud like AWS, Azure, or Google, or it can be multi-cloud. This is just this infrastructure as code is honestly, it's really cool. Code artifacts. AWS Code Artifacts enables users to store software packages used during application development. The packages are stored in a repository like GitHub so they can be accessed for future use or reuse. Packages can be simple files, reports, or logs. The benefits of Code Artifact: it reduces delivery time by encouraging code reuse, which always is good. It's fully managed, so AWS, so there's no management of it. And there's no limit to the number of packages that can be stored. Christian asked a great question. I'm going to take it as we go. CloudFormation versus Beanstalk. Beanstalk was AWS proprietary means to do things. CloudFormation is a much bigger, much more capable way of deploying things. And Terraform is the standard to use on all clouds in today's modern world. So CloudFormation is a much better option because it's not automatic. You tell it exactly what you want. Data exchange. The AWS Data Exchange is a data subscription service that allows the exchange of data between organizations. Customers can subscribe to various published data through their console, and the data can be used for data-driven decisions using analytics and machine learning. Anytime you get better information, you got better things. On the AWS Data Exchange, data providers can host various data such as payroll information, credit card transactions, healthcare, and demographic data of most AWS customers. The data that is provided as a data product is provided as a data product, and the customers can subscribe to it via the console. Data in AWS Data Exchange is organized in three ways. It's either an asset, which is a piece of data. It's a revision, which is a container for one or more assets, and it's a data set, which is a series of one or more revisions. Data exchange allows customers to migrate to the cloud with existing subscriptions by third-party approved service provider or data providers. Let's talk about device farm. I don't know how they make up all these names. AWS Device Farms allows developers to test their applications using virtual devices available on the service without the need to buy them. So you want to test code on an iPad, an iPhone, an Android phone without actually having them. That's what Device Farm is. There's lots of virtual environments like this, but this is the AWS branded one, and it enables developers and developers to test their environments in an automated environment without having the gear, which is nice. It enables automated app testing. Users can upload and choose the application to test, select services and operating system versions and the number of devices that are going to be used for the test, and then run the test and get the results. Users can select as many different kinds of virtual devices as possible, large numbers of operating systems to get the desired outcome and confirm the application works. It's kind of great. Remote access integration. Users can set up a virtual device and interact with it remotely while achieving real-time outcomes on the virtual device. Forecast. So many of you are not familiar with businesses, but businesses have to forecast. What are we going to sell this week, for example? What are we going to sell this month? What are we going to sell this quarter? What do we need to sell this year? And you need that information so you know how many people to hire, what your marketing budgets are going to be like, how to reach your customers. The better an organization's forecasting is, how much stuff they need to stock, the better their profitability is. And there's lots of tools out there to forecast. And it's going to be still a bit of a manual process with your business executives and whatever tools that you have out there. So Forecast is an Amazon branded machine learning tool to assist with business forecasts. It works on time-based data analyzing all this data first, the newest data, to help businesses look at historical data and hopefully make better predictions for the future. Forecast works by using machine learning algorithms to combine historical time series data with other variables to build accurate forecasts. To create a forecasting project in Amazon, users work on the following resources: imported data sets, training predictors, and generating forecasts. Amazon Forecast is used when you want to predict business outcomes accurately. It's useful for operational planning. Let's say you want to better figure out what your business operations are. Supply chain planning, know what to stock or inventory versus what not to. Retail demand, resource planning. Now keep in mind this is an automated service. There are data scientists, which are specialized experts that know how to work with all the best tools to help businesses make better business decisions. And data scientists can use these tools plus a variety of tools. And as GPUs get better and better and better, and organizations figure out how to use data better and better and better, I think we're going to see a lot more in some of those things. But this is an option, along with many, many, many other options. The more automated, generally speaking, the less functional it is and the less customizable it is. Let's talk about Global Accelerator. Global Accelerator is another AWS managed service to optimize communication and data transfers between two endpoints. It provides an optimal pathway for data exchange between the end user and the application endpoint. The way this works is Global Accelerator brings the application user closer to the user on the public internet. It uses a technology called Anycast, where you've got the same IP address in most places, and then it uses internet routing to help you get to the closest Anycast location. So if I need to go to Philadelphia to then reach the data from Palm Beach, Florida, there'd be delays. But if from Palm Beach, Florida, I can get on in West Palm Beach or Miami, Florida, for example, the latency is less. So Global Accelerate is a service to help you connect to the AWS resource on the internet faster. Quite a good service, actually. Let's talk about Managed Grafana. Managed Grafana is a service to use to enhance productivity while making use of Grafana applications by taking away the burden of self-management, thereby enabling the users to focus on something else, another managed service. Grafana is a common open source analytical platform that is used to visualize, query, and understand metrics stored anywhere in your production and data environment. It's serverless and secure data visualization service. Users can instantly correlate and visualize metrics, logs, and places. It's highly scalable. It provides a single dashboard containing all integrated resources and tools. It's highly interactive data visualization that's effective for real-time monitoring and data operation. Grafana is going to allow easy integration with open source AWS data sources, third-party, and other common cloud data sources. It supports that security assertion markup language that we talked about yesterday that's typically used for federated identity management. It's highly secure, ensuring data privacy and protection, and it eases the stress of doing licensing and setting up your virtual machines because it's a fully managed service. OpenSearch services, I don't know which marketing people actually can make all these names. OpenSearch is an open source services that allows users to search, analyze, and monitor large volumes of data from multiple sources. It incorporates visualization tools that provides insights into unstructured and semi-structured data. Additionally, open source integrates well with analytics, machine learning, and other database mining tools. When the data is captured and loaded into OpenSearch, it's going to use built-in services such as Kibana, full text querying, autocomplete, and scroll text to search, visualize, and analyze logs to get real-time inserts. I mean, there's so many versions of these same things with different names. Now let's talk about Proton, another service. Proton is an automated application delivery service focused on containers and serverless workloads. Proton enables platform teams to enforce controls and best practices on the underlying infrastructure. Proton service separates the infrastructure and the code, enabling collaboration between infrastructure teams and development teams so they can simplify coding, provisioning, etc. But now you lost control. So is it good? Is it bad? It depends. Proton provides the offerings such as infrastructure as code, CI/CD pipelines for the DevOps people, and monitoring, and an efficient way for containerized and serverless applications deployments. Those templates can be replicated across various deployment, staging, and production environments, and users have the full capacity to manage, update, and troubleshoot. It's another tool for DevOps engineers. Of course, there's lots of tools to do these kinds of things. Now we're getting into something that I think is really cool, and all the cloud providers have it. Let's say you don't feel like learning any of this AWS stuff as a company, but you still want to use the AWS cloud. And in your data center, you've got VMware, which is what every business has if they don't have Nutanix or OpenStack. And you want to leverage the scalability of your resources and the agility of the cloud, but meaning like the ability to get servers faster, but don't want to deal with any of this nonsense. Welcome to VMware on AWS. So VMware on AWS is an infrastructure as a service that basically you're getting AWS bare metal servers and you're running VMware on it. And this means you can run the same VMware servers, vSphere, Virtual SAN, Virtual NSX virtual technologies in the AWS data center with the platform that you understand, the technology that you understand that your people have been using forever. Think there's a shortage of cloud engineers? Not if they use VMware on AWS, because they can do the same stuff they've done for 2 decades with the same interface. And that's why you see VMware on Azure now, VMware on AWS, and I think there's even VMware on Google Cloud. Want to leverage the cloud without knowing the cloud? There you go. Because all data centers have been running their own clouds for decades now anyway. And now they got the simple and elegance of VMware that everybody knows on the public cloud. Same VMware tools. So really kind of great. So this enables customers to quickly add capacity from 2 different clouds at the same time. Don't need to know any new technology because it's the same stuff. As I tell you, the cloud is just a virtualized network in a data center. VMware has been doing that since 1999. Woohoo! Now you've got the same thing. I love VMware. And I run VMware servers all over the place. Got about 6 of them in my house and a bunch of OpenStack ones in my house as well. Incredible what you can do with it. And the service is obviously going to run on bare metal AWS infrastructure, just like a server you would get from Dell. It's just AWS already has it there. So very simple data center migrations, rapid disaster recovery, flexible dev test environments. It is fantastic. Wavelength, AWS Wavelength. So an AWS wavelength zone typically exists outside of an AWS data center, and you can use this to create your virtual machines, EC2 instances, your block storage, EBS, and your virtual private cloud subnets and AWS wavelengths, and use services to orchestrate them, such as Amazon Kubernetes services and Amazon Elastic Cluster Service and AWS Wavelength. Realistically speaking, the infrastructure is deployed on 5G communication service provider networks. And we can use this when we need to do some edge computing where low latency is needed. AWS Wavelength is an infrastructure deployment zone that is embedded in the telecom provider's facility. This can be compared to a local zone that works with any AWS availability zone. Here's the key. It's getting your stuff closer to the user. You want to learn a lot more about edge computing. Read the blog article that we co-authored with Eva Dykja. She really put a great thing together. It's on our website. So what happens is by using the computers on the edge, we're saving milliseconds of latency. We've got all of our, let's say we've got a bunch of weather sensors that are all going to an edged environment. We can do the computing right on the edge without routing it back to the cloud or your data center and save milliseconds of latency. And for latency-based things, potentially even a video game, this could be really great. So what will happen is the service provider is going to have their data centers, which are going to be where their 5G network is. And that's where Wavelength is. Let's talk about X-Ray. Amazon X-Ray is a tool used to troubleshoot and identify root causes of performance issues in AWS and errors in AWS services. X-Ray typically looks at API requests as they travel through your application and produces a map of your application, and developers can use the AWS X-Ray service to analyze and debug their applications. AWS X-Ray provides a full view picture of the requests that are passing through the user services. And it helps see who made the request for the service, when the request was made, for example, when a reply came back. AWS X-Ray collects data from the applications or services running in your system and kind of aggregates them together to form traces of each application and service. It then creates a service map or a visual representation that can be used to trace or debug. And then you can further drill down into each service to see what's going on with your applications. Benefits: it helps with auditing purposes to trace requests, helps you find a detailed service map of your applications, assists with finding bottlenecks in the architecture so you can improve performance, and identifies errors or bugs in your services. Okay, next up is containers. Any questions before we move on to containers? And while we wait to see, if you haven't liked the video, please like the video. Please make sure you sign up for next week's How to Get Your First Cloud Job webinar, because I want everybody hired. Ken Sharma, starting, you think you weren't kidding when you said they like to use 10 versions of the same thing with funny naming conventions. No, I wasn't joking at all. Not one bit. Yesterday you said practicing with labs is those for constructing is not necessary for architecting. How can one cement or reinforce the knowledge they learn as an architect? With design documents, with blogs that show how the technology can improve business performance. I'm going to make this very clear. Like, I have my hammer out from last night. This is what a construction worker does. They hammer in nails. They use this thing my brother told me was called a wrench. Now, the people in building construction that use these tools don't get asked to design a hotel, because building teaches you nothing about designing. And while I said, do the lab so you can say you've done it, I'm going to make it very clear. I've got engineers with 20 years experience. So yesterday night, we were on a How to Get Your First Architect job. And architects are not allowed to touch the technology. We don't touch it. Architects design, present, and tell. So learning how to use tools is no benefit to the building architect, and it's of no benefit to an airplane pilot to have experience fixing airplane engines like an airplane mechanic, and there's no benefit for a doctor to be a nurse before they became a doctor, because we were talking architects. For engineers that build stuff, they have to get hands-on, because engineers build, and engineers to be hands-on. An architect and an engineer are two very different things. The same way an airplane pilot and a flight attendant have different jobs. A flight attendant keeps passengers in their seat, hands out foods, beverages, and meals. Do you think practicing that would get somebody interested in, would have an employer say, yes, I want you to fly my airplane, you've been a flight attendant? Of course not. So architects write design documents, which is, they respond to RFIs, RFPs, RFQs. Architects build teams. Architects present at conferences. Architects sell. Architects have to ask this chief information officer, what are the business goals? The chief executive officers about the revenue projections. So it's a completely different skill. So, and that's why in our Cloud Architect Career Development Program, we do have labs so people can say they've done it, and we leave them as optional because architects don't touch the technology. Engineers build it. So we talk about specificity of training. So yesterday I said that a gymnast should not train the same way as an Olympic weightlifter because it's a different sport. So architects don't construct. And if you tell me, and if I was interviewing you, and everything that we just talked about is in our program, all of the architect things. And Sarah, that's why we take people that are engineers with 20 years experience and retrain them to be architects, because they've got lots of experience configure things, but they have no experience in designing, presenting, and selling things. Likewise, an architect who designs, presents, and sells, but have no knowledge on how to be an engineer. Different jobs. Igor, a little unrelated, solution architect, associate, or professional, how much harder it is? You're not talking anything that's really complicated in either case. The complication, Igor, is this. The concepts are easy. The way the questions are asked are really, really, really bad. So, Igor, the key to being successful with any of these things is practice test to get used to it. And Igor, that's why I know lots of people who pass the certified solution architect professional with zero experience in less than 2 weeks. And I know other people that actually know the material really well who can't pass it at all because of the way the questions are asked. So get a good practice test. How do you draw architecture requirement documents? Well, it depends on your level. And if you're a senior level architect like I was, you draw them on either in PowerPoint on a piece of paper, and you have it scanned in and you send it to somebody to draw the graphics for you in Adobe InDesign. Or you can use Visio, you can use Lucidchart, Draw.io. And Pradeep, it is not easier to go from engineer to architect than not engineer to architect. Easiest to go from sales rep to architect because it is much more inclined with selling than it actually does engineering. I've got people and I get them architect jobs. They can come from engineering and they can come from architecture. When they have an engineering background, they typically get a higher starting salary because it looks good on their resume. But the engineers that I have with 20 years experience often tell me it's harder for them to forget how to be an engineer and how to think like an architect than it would be if they just trained to be an architect at the same time. So join us on Monday on our Cloud Architect or Cloud Career question and answer session. We can talk about it, or join us in the next How to Get Your First Cloud Architect Job webinar. I was just answering the questions that popped in. Let's get back to the content. Let's talk about containers. So realistically speaking, we talked about what a virtual machine was and what a virtual machine is. Now, we talked about when you create a virtual machine. Let me draw it again as a refresher for everybody before we start talking about containers, in case you weren't here on Monday, for example. So when we're dealing with a virtual machine, we're going to be dealing with a server. That's the physical hardware you buy like from Dell, IBM, HP. On top of the server, we're going to have this software layer called the hypervisor. And then what we're going to be doing is we're going to be creating virtual machines. Now, each virtual machine is going to be allocated a certain amount of CPU resources, and it's going to have an operating system on top of it. And then we're going to have this additional stuff on it, which is, let me just make this a little taller to make it simple. And we're going to have the app and the dependencies. So that's a virtual machine. So what happens is, a server running a virtual machine, let's say the first virtual machine is Windows, the second virtual machine is Linux, the third virtual machine is Linux, the fourth virtual machine is Linux, the fifth virtual machine is Linux, and the sixth virtual machine is Windows Server. Now, every time we run an operating system, that takes a lot of CPU, memory, and disk overhead. A lot of it. Now, because each one of these operating systems takes so much memory, these operating systems really eat up a lot of the capacity that's available on the absolute server. So it takes up a lot of resources. Now, if there was a way that we could multiple applications on the single server in an isolated environment where we don't have to keep having versions of the operating system like over here, and we're going to just pretend you didn't see this Elastic Container Service here right now, because that's a service you probably should never use, and we'll talk about it in a minute. But we'll just talk about the container environment. We've got our server, our operating system, and then each one of these things has its container. Now, with every container we're talking about over here, it's really cool because container one is completely isolated or container 4 is completely isolated from container 3, which means if container 4 crashes, for the most part, it shouldn't affect container 3. If container 4 gets hacked, theoretically, it won't affect container 3. So it is a beautiful way. Plus, not having the operating systems, if a virtual machine might be able to support, if a server might be able to support 10 virtual machines, then maybe over here, we can support 50 containers on the same server. So very fast. Now, anytime we're dealing with containers, we have to orchestrate the containers, which is where do we stick the containers, and then we need compute for the containers. Now, AWS has a very proprietary service. This should be on your banned list of do not ever think about using, called Elastic Container Service. And what that is, it is a fully managed service to orchestrate your containers. Why should you never use this? It doesn't work in multi-cloud. And 98% of organizations use more than one cloud, which means this service is not only ready for the trash, you should stick it in the trash can and burn it and not ever think about it. Because it is a proprietary container orchestration management. Sure, you'll probably see lots of the reasons on your exams to use this, because they want you to use this because then you are stuck and it is hard to leave AWS. So we like the containers because they use less memory CPU. And the point is you make your container and you can pick up the container and move it to another server, move it to another server, move it to another server. So we love containers. We just recommend against the Elastic Container Service. We'll tell you what to use instead. But if you didn't want to manage your containers and you didn't have anybody that knew how to manage your containers, that's what this service is for. It's trying to take the expensive personnel out of your cloud engineer and try to make it like a cheap person that costs very little. And that's what the service is for. Because if you don't have to know anything and you just click a box, it works. Until you use multiple clouds, in which case it falls apart. So don't use this. It's a 99.99% availability service, which means it's not high availability enough for mission critical things like a bank. And basically you deploy it in a VPC and you can secure it with access control lists like networks and security groups. And you can stick your actual containers on either something called Fargate or virtual machines. We'll talk about that later. Visually speaking, what the service is for is you've got two options. You would create your container and deploy them on a virtual machine. Then you're going to provision your container management platform, and you'll isolate your applications each in different containers, manage them, and pay for the virtual machine. The alternative is, and we can do this with anything we use, is to actually use something called Fargate. And what Fargate is we basically build our containers and we stick it in a serverless hosted environment that gives us all the compute power we need, auto scales up, auto scales down. And that means you don't have to manage the virtual machines. Great. On your own virtual machine, you've got as much control as you want. On serverless, you've got no control. So do you want fries with that, like at McDonald's? Serverless. Do you want to customize that? Like one of my Greek relatives that has a great Greek restaurant, and I'll ask him how to make my hamburger or chicken sandwich the way I want. Lots more customization than at McDonald's, but McDonald's is faster and probably cheaper, as Fargate's pretty fast, and in many cases is cheaper, unless you use it a lot, in which case it's not going to be cheaper. So keep that in the back of mind. So if Elastic Container Service is the proprietary thing, what is the non-proprietary thing? Elastic Kubernetes Service. So before we get into Elastic Kubernetes Service, someone asked a question earlier, I believe it was Naga. There are two ways to set up a Kubernetes cluster. Cluster one, create a couple of virtual machines, install the Kubernetes orchestration system on it, and put some of it in every cloud and connect them together with IP connectivity. There you go. And we're talking about these things. The containers will be managed by your container orchestration service, which your options, realistically speaking, in the modern world is Kubernetes. Where Docker is a container runtime module, Kubernetes is the orchestration platform, the management platform. Kubernetes also now has its own runtime platform as well. At least I think it's going that direction. So When it comes to Kubernetes, build your own servers or use the Amazon Elastic Kubernetes service. If you use the Amazon Elastic Kubernetes service and you're multi-cloud and Amazon Cloud goes down, all your availability, redundancy, and all that great work that you did is now thrown in the trash. So don't recommend you use this. I recommend you build your own Kubernetes cluster. But if you're going to use a managed Kubernetes, a managed container cluster, because you don't want to build it yourself, your team doesn't have the sophistication, don't use Elastic Compute Service, use Elastic Kubernetes Service. And what is it? It is a 100% fully managed container management or orchestration service. So if you're using Kubernetes in the data center and you've already got your Kubernetes containers, you can just bring them straight over to the cloud with no modification whatsoever, because it's an open source container management service. And it uses the standard, the Kubernetes standard, which was invented by Google, of all people. And so proprietary cloud, don't use single cloud. This is fine. Multi-cloud, do not use this because if the AWS cloud goes down, even though it's not proprietary, everything is lost. So kind of figure out what you need to use. So, but it is the open standards. It does follow the standards. And here with Kubernetes, we can use Kubernetes, what we're actually talking about, to orchestrate the platform. But we still need some place to house the computer. So we've got two options. Again, we can set up Kubernetes and to manage the orchestration. And Kubernetes is, a pretty significant thing. When it comes down to it, you got to look at everything that goes into it. And it's not complicated like networking, but it's far more complicated than many of the other things that are out there because it's open standard and it's robust and it's got a lot of use cases. But, interoperability, and multi-cloud, I'd be building my own cluster or having my engineers build it. But here, and Amazon's got, Microsoft's got their own managed cluster. Google's got their own managed cluster. So we've got our cluster management, and you can put your cluster, your containers on virtual machines. You can stick them on Fargate, which is a serverless environment to house your virtual machines. So it's like anything else. Next, we'll talk about EKS distro. Now, if anybody wanted to trap you even more into not leaving the AWS cloud, we've got EKS distro. And what is this? It's an Amazon managed system, their Kubernetes customized deployment thing that you install in your own data center. And that way you can run this Amazon thing in your data center as well as the AWS cloud. And that's how they're getting around people that are increasingly adopting hybrid clouds and still using some version of EKS. Build your own cluster. You don't have to worry about any of this stuff. And you're not beholden or dependent upon anyone. You're not handcuffed to anyone. Your customers have the freedom to go wherever they want. But what is EKS distro? Because it's an AWS exam. It's a service that enables your users to run containerized applications in the data center the same way you run them on AWS. It enables your users to create Kubernetes clusters with the exact version of Kubernetes that AWS would use. The main difference between EKS and EKS distro is that EKS is fully managed, whereas AWS EKS distro is available to download and install in your data center, but you manage it. Users can deploy Kubernetes clusters to match their EKS clusters without having to worry about anything. But again, you can just build your own. EKS distro can be used for hybrid clusters. That's what it's used for hybrid clouds. If users want to use Kubernetes clusters that span their data center and the cloud. It can also be useful for disaster recovery. For example, you can set up AWS to be the backup data center if it goes down. Now let's talk a little bit about Elastic Container Registry. Now, typically speaking, we have Kubernetes, which kind of orchestrates what goes on. And our containers often need a container runtime module, such as the Docker. And you would take a virtual machine, you'd install Docker on it. The Elastic Container Registry is a product that stores and manages your Docker images that are managed clusters of virtual machines. And it basically enables you to not have to think about managing Docker. Elastic Container Registry provides a command line interface and APIs to manage repositories such as Elastic Container Service that installs infrastructure for containers. ECR is secure, scalable, and reliable service that distributes applications faster. Now we'll get into EKS Anywhere. It simplifies applications on-premise Kubernetes custom management data via default configurations. It offers consistent and reliable Kubernetes cluster management on-premise, better than in self-managed, or they say it's better than self-managed. That's a marketing term. It reduces support costs because you have less to know. Okay, we'll talk about some IoT services next. And then we'll get into, after that, we'll talk a little bit about cost management. At least we'll talk about AWS versions of cost management. And we'll talk about how do you pass the exam. So let me, let's go to the next content. Let's see if there's any quick questions.
You may have answered some of these, so just let me know as they come up.
What is the difference between a container and a pod and an image? A container is that entire environment that's got your application and application dependencies. A pod is part of Kubernetes and the way they describe some of the way things run. If we were going to talk about Kubernetes, we'd probably need about 12 hours. But what you can do is you can go to the Kubernetes page and they'll explain kube and kubectl and pods. It's quite good. And that. So let's go to the next one, Chris. Are these containers managed by Docker? No, the Docker doesn't do any container management. It's a runtime module. Is Elasticase not proprietary? Well, Steve, it's kind of an odd one. Elastic Kubernetes is not proprietary, but it's hosted directly in the AWS cloud, which means if the AWS cloud goes down, all your other clouds that you might have containers in goes down. So to really do it properly, you're going to have to manage your cluster and all different things. So it's not that it's proprietary, but it's kind of like you go to all the effort of work to use 3 clouds, and then you use this thing that only works that's proprietary to AWS. Well, not proprietary, that runs in AWS. Then AWS has an outage, and all the work that you actually did to have multi-cloud and all the expenses is all wasted. So I wouldn't be using it. EKS isn't enough. You need to consider the full stack. Absolutely. Everything. It's not just EKS. You got to look at which is better, self-managed, self or managed. Though, Pradeep, here's the secret. There is no such thing as what is better, ever. There's no best technology. There's no best coding language. What business problem needs to be solved, and that's the right technology for it. If you're only going to be in AWS, which I can't imagine why anybody would, 98% of businesses use more than one cloud. But if somebody was like a supermarket, like the American supermarket in my Greek village, there's only 5,000 people there, it may not make sense for them to be in AWS and Azure because it's a small business. So for them, if they were going to be using EKS, they probably would use the AWS EKS because it's simple. Now I got a real business. I got a bank, right? The bank, a minute of downtime costs them $10 million. AWS cloud goes down, and they've got this EKS operational, and then everything falls apart. So what are the business requirements? They determine the best technology. I've worked with companies where an ice machine could save them millions of dollars a year, and I'm not joking. And I've worked with other companies where it takes a complete technology re-architecture thing, and I've designed billion-dollar architectures and little mini $100,000 architectures, $200,000 architectures, which are nothing in the grand scheme of things of technology. And I've done many 200,000. I've done a lot of $50 to $100 million architectures, but it's best tech, whatever is the business. Can Kubernetes be used as a layer of multiple cloud providers? Mohammed. So let's say in 2014, we decided to stick Kubernetes in 15 data centers, like Google's done probably in 100 data centers, or some ridiculous number. Of course, it's no different. A cloud is just a data center. And any way you connect your data centers, it's the same way we've done it for decades. So yes, it can be used across multiple cloud providers, should you have IP connectivity. Daniel, do you need to memorize all of these services for the exam? Well, I'd say 75% of these things are going to be on your exam. 25% of these are from the Certified Solution Architect Professional. What happens, Daniel, is AWS changes. This month they want to add this service. This month they want to add another service. So to give you guys really good knowledge and not knowing what's going to be on the SAACO3 exam today versus tomorrow, I give you more than you need to know. I come from a world where it's better to be over-prepared than under-prepared. So I've given you more. So I strongly recommend that you get a practice exam. There's some great practice exams on review and prep. Haman Sharma's their CEO. I know him. He's a great guy. I don't get any kickbacks or anything from recommending it. I also think a lot of Andrew Brown in Exam Pro. He's got some very good certification materials, which I believe are free or very low cost. And he also has some practice exams for a small fee. So I would get a good practice exam that are out there to get used to the way AWS answers questions. But yeah, so I'd say 75% of these things you need to memorize to pass for the exam. And you got to think like AWS, and what's their goal is to get you to use their stuff. So almost on an AWS exam, whatever uses the most AWS service, which generates the most revenue, often feels like the right answer. Not always, but a lot of the times. Have I seen real world use cases where applications are deployed across multiple clouds? Of course. Of course. I don't know anybody, the customer that I would work with, that would only use a single cloud. I can't find a single person. I don't work with small businesses because my skills don't really apply to little businesses. They apply to global businesses. And there's not a single global business in the world that wouldn't use multiple clouds. And I've not done this for decades where we haven't deployed applications across multiple networks everywhere. This is not new. This is the way we've done things for the last 25 years. Can a single container run multiple applications? That's not the way it's worked. And a single host can run multiple containers, and each container runs its own application. That's the best practice. Apart from Docker, who are the everything? So Docker is a runtime module. It's not a container image provider. I believe Kubernetes and newer features is also allowing it to run it itself, but that's what you're using. You're using a runtime module. So Docker is the runtime module. So let me draw that out for you because I think it's probably a reasonable question that you're asking. So here's realistically speaking what we're talking about with Docker. So up here, let's say here's your Kubernetes. It could also be ECS, but I wouldn't be using that for any reason. So here's your Kubernetes. Down here, you've got your physical server, and the server has its operating system. And then the next thing that you actually have is you have something called, you have a container runtime software. Now, this is typically where Docker plays. You got the intelligence coming from the Kubernetes cluster, the ECS cluster, and that's managing the containers. When the containers go up, you can specify 5 containers. If a container crashes, you're down to 4 containers, Kubernetes will say, hey, self-heal and add a 5th container. Kubernetes is exceptional. But that's realistically what's going on. You've got your server. And Chris, if you want to remove that thing from SBAT so people can see the picture. Because you've got your server, the operating system, and then the runtime module. And the management, all of this is done by Kubernetes. So the way I like to look at this, if any of you ever been to an orchestra or seen an orchestra play, and you got this conductor waving his arms and he's telling the people to play louder, play softer, start, stop. Looks like a great workout for whoever's swinging those little things. That's Kubernetes. Now, you can think of the containers as the flutist, the harpist, the drummers, the whatever those things are. They clap together, all those kind of cool things. I like classical music. I mostly like reggae, but I like classical music. And X-ray is required to invoke an API. Yes. This is time consuming from a developer. Yes. Are there other observation tools? Many observation tools. I am an architect and not a developer, so I really, unfortunately, do not know much about developer tools because architects and development is just completely different parts of the world. But you can look up developer tools and find lots of them. How to ensure multi-cloud and an active config with data application with less than 1 second or reasonable failover. We're not going to get less than 1 second failover. We can get less than 1 minute failover, which is realistically speaking what we're doing, maybe 2 minutes, but we're not going to get less than 1 second. The only time we can get less than 1 second failover is for an architect like me to create a very private data center or multiple data centers that run an interior gateway protocol, such as a single area OSPF or a single area intermediate systems to intermediate systems. And then inside of that, we can turn on some label switching or tag switching for MPLS. From there, we can use RSVP to signal some MPLS tunnels. And from there, we can create a primary and a backup explicit path. And we can do these kind of incredible things in the data centers or in our private clouds. But in a public cloud, we're not going to get anywhere close to that. And that's really the difference between heavy-duty infrastructure architects that know how to do this stuff versus the cloud, where when you go to the cloud, they do most of this stuff for you, but you can't get that level of performance. There's just no way to do it. But 90% of organizations don't need a 1 second failover. And the convenience of the cloud often outweighs the need to have people like me, these senior network architects that know how to do these things. Let's talk about IoT services, because IoT is where it's been at in the last 10 years, and it's growing and growing and growing. IoT is Internet of Things. So any IP-enabled thing, think of Internet of Things. The refrigerator that you've got that's connected to the Internet, Internet of Things. Your iPhone, Internet of Things. Some people have watches with an IP address on them. I don't know what they would want to do with a watch that's got an IP address. I like my old kind of thing that's got seconds and minutes and a date. But there are people that are running like watches that have IP addresses on them. Your car has got an IP address on it in many cases. Weather sensors have IP addresses, and that's what we're talking about, Internet of Things. Biomedical devices sitting in people's houses, Internet of Things. And typically speaking, you got the device, and it has to communicate to something. And there's lots of people that make this kind of stuff. Cisco's been in this business for like 2 decades now. AWS is also working with IoT. First service we'll talk about is AWS IoT Core, which is a cloud service that acts as a communication gateway message broker device application interface for the devices themselves, like your IoT-based watch. It's the foundation for Amazon's comprehensive solution when deploying, managing, and maintaining Internet of Things devices so that the users don't have to manage a lot of infrastructure. AWS IoT Core provides a scalable and AWS maintained solution, so you don't have to think about it, that provides secure connectivity to and from devices, provides rule-based data traffic manipulation, and IoT command and control. So they manage these things. It can reduce the operational burden of IoT devices by providing a platform that supports communication and management, because these things are complicated to manage. The service facilitates communication from device to cloud services, applications, and devices. It has built-in authentication, authorization involved. It's got a RESTful API for command and control to multiple IoT devices. And this service, realistically speaking, is beneficial in a scenario where people need to command a fleet of IoT devices. This gives the end users access to information that can analyze, process, and make actionable decisions. What's it going to look like? It's going to look like something like this. You got your Internet of Things devices that are connected to this core service. and it can connect to things. Now, think about this. Most IoT devices can go down for 5 minutes, 10 minutes, and nobody's going to die. So in many cases, we could use a single cloud in an environment like this for IoT core. But if we're using it for IoT for airplanes, well, that can't go down, and there would need to be multiple clouds because we can't have planes bumping into each other. But if we're using it for things that are non-critical information gathering, then we could potentially get away with a single cloud. So anything with architecture is business requirements. So this can also be used for IoT device management as another service. And it's a device inventory and management service for internet connected devices. Organizations can use the AWS IoT device management, can easily register a device with regards to information configurations, organize their device inventory, monitor them, even update the firmware. The service helps track, monitor, and manage the fleet of connected devices. It can even give you access to the health of the information, like health monitoring of the device, can help you troubleshoot problems. Let's talk about AWS IoT Events, which is going to be a cloud-based service that continually monitors data from applications and equipment for any changes in daily operations. If an event occurs, it will trigger the right response. IoT Events runs serverless, and there is no host, so there's nothing to manage here. IoT Events monitor ongoing data from IoT device sensors and applications to integrate with other services like IoT Core, IoT Analytics, to help you get actionable insights from your information. IoT Events will monitor equipment or devices for failures, and when something happens, it'll trigger an action. So think of a CloudWatch event, an IoT event, same kind of thing, but a different platform. Users can take inputs from multiple sources and are able to move a device from the IoT core. Users can also route sensor data to IoT events. IoT events are consistent with processing messages and consistent in reporting. Actions take place in near real time. Let's talk about IoT Things Graph. AWS IoT Things Graph is a service enabling non-developers to visually create workflows between physical sensors, physical app sets, and web services for building network solutions across physical and virtual things. It can quickly build and deploy IoT applications by connecting devices and web servers from different vendors that speak different protocols. The visual editor in AWS IoT Things Graph can wire together devices and create a series of steps called a flow. A little bit about AWS IoT Analytics. Now it's analyzing things, right? So let's say you store data and you want to be able to look and perform some IoT queries. You can take prepared data, which is easily processed and analyzed. And this way we can predict maintenance of things that we need to do on our IoT fleet, like predicting when things are going to fail. Helps us build applications and monitor inventories in real time. Okay, now we're going to get into cost management. Okay, so this is coming from an AWS perspective because this is an AWS exam. So for the things that we're going to tell you here, we have to say this because you will see this on your AWS exam. I will say this, when you move to the cloud, it will have a profound effect on an organization's costs. In some situations, it reduces them dramatically. In some situations, it increases them dramatically. Theoretically, a move to the cloud should have a lower total cost of ownership, meaning you pay a whole lot more for everything, but you need much less people, so it might be less expensive. And moving to the cloud will definitely do one thing. It will change the organization's capital structure. It will change from a capital expense, I buy it, to a operational expense, which is where I pay it monthly. Is this better? It depends. You know, to really know these things, you need to know the organization's weighted average cost of capital, their capital structure, and that way you can figure out their borrowing costs, where their money is, to make a determination with it's a good move to go to the cloud or not. We obviously teach these things in our cloud architect program because because cloud architects have to do this. They can't just say, yeah, cloud's cheaper. They'll be fired on the first day. Now, data centers traditionally have high capital costs. Now, this does not mean that a company has to buy it. It's like buying a house. Most people don't pay cash for their house. They finance their house. Businesses don't write a check for their technology. They either finance it or they lease it. So again, cloud, monthly payment on the cloud, like rent, buying payment in the data center. It depends. But data centers typically have very high capital costs because you buy the servers, you buy your routers, which send your data from point A to point B. You buy your switches, which is typically where your stuff plugs into, like your servers. You buy your firewalls, your load balancers, your racks, your power distribution units, your generators, your UPS systems, your battery backup, your cooling equipment, and your real estate. In the cloud, you don't buy most of this stuff. Now, in the data center, your operational expenses or ongoing expenses are related to your staffing, your electric bills, and your networking connections. Most of the costs are for your equipment. In the cloud, everything changes. For example, $140,000 server in the data center costs you 16 grand a month in the cloud. I'm not joking. We recently did the math on something like that. So let's think about this. So if you take 16,000 and you can use that cloud for 4 years, which is 48 months, the server that you buy from Dell for $140,000 costs you $768,000 before discounts on AWS. Is that saving you money? I don't know. What are your support costs? What are your data center costs? These things have to be calculated. But ongoing expenses in the cloud are expensive because it's rent. So in the cloud computing environment, there's minimal equipment to purchase. Is that good or not? I don't know. It's based on your customer. However, in the cloud, you're going to pay to use it, and you're going to pay heavily to use it. So it's a shift from CapEx to OpEx, good or bad. And that needs to be planned ahead of time. Otherwise, you go to the cloud like so many organizations have done, and then they find out that it's double the price that they had in their data center, and then they go back to their data center and they go back to the hybrid cloud, which would have been right for them in the first place. Some people are best all cloud. Some people are best all data center. Some people are best multi-cloud. Some people are best hybrid cloud, multi-cloud. It all depends. So how can you minimize your costs on the cloud realistically? First, only provision what you need. Okay, well, if you need one box of coffee, don't buy 50. Okay, these are Amazon's guidance. Two, monitor your systems. If you build a system with 64 cores and a terabyte of RAM and you find out it's operating at 3% utilization, shrink it. Shrink it to whatever is an appropriate size. So properly size your resources. Here's where the cloud is cheaper. In the data center, we plan for peak. I've been talking about Taylor Swift all week. Taylor Swift has a brand new perfume, right? And she's going to tweet about it and post Instagram about it and Facebook about it and make a TikTok video about it. I got in the data center. I got to plan on the biggest, baddest servers in the world for when that occurs, or the Christmas holidays. On the cloud, what can I do? I can buy what I need average side and enable auto scaling when I need it. So web resources are typically cheaper on the cloud for that reason, because you can buy what you need and add capacity on demand. Now, if you decouple your systems by using queues like a Kafka queue or an SQS queue, you can use smaller systems and store messages. So decouple your systems to optimize your costs. Purchase the right platform. So what do I mean by that? We talked about when it came to your virtual machines, which ones do you use, right? Well, if you know that you need a 24-core server with 128 gigs of RAM and it's running smoothly and you're going to need 3 of them for the next 3 years, reserve them and get a discount. If you don't know, use on demand. And as soon as you know what your capacity needs are going to be, reserve them and get a discount. If you know you got a batch job every Saturday and Sunday, use scheduled reserved instances. Now, if you've got an unimportant thing where you just need a lot of compute capacity really quick, and you don't care if it gets shut down because it's not that important to you, then you can use something called the spot instance. Step 4, according to them, use managed services and serverless. This one makes me cringe when I say it. The second you lose control, everything gets more expensive down the line because you lost control. And when you lost control, you lose bargaining power. Step 5 is managing your data transfer charges. We got to look at it this way. In the US, if I buy a 10 gigabit link, I pay once per month for the 10 gigabit link. When I connect to AWS or Azure or a cloud provider, I pay for the same price for the 10 gigabit link. Then I pay a daily fee to have the link, and then they pay me to use the link, which could cost me 5 times more than the link itself. So manage your costs of your networking costs. So, if you've got an S3 bucket that's in the US and you've got users in the UK that need the same thing, instead of paying inter-region transfer charges, enable your S3 bucket to replicate itself. Use CloudFront to serve locally so you don't have to do inter-regional transfer charges. And on your networking, it may be initially cheaper to use a VPN if you don't use it a lot, but it might actually cost more than a private line if you use it a lot. So you really got to look at these things. Now, you can set up a budget, and AWS budgets are really good at this. What happens is you set up an alert, and it's going to tell you, hey, guess what? You're almost used up all your budget ahead of time. So the way a budget's going to work is you create a budget, and then you get notified. Hey, you've used 50% of your budget. Trusted advisor. Okay, so a trusted advisor is a person that goes to an organization that has no bias and the organization trusts, so they listen to the recommendations. AWS has a service called Trusted Advisor, which is a tool made by AWS to help you maximize your return on investment from AWS. So it's going to compare what you've done to what AWS thinks is best practices. And from then, what it's going to do is going to give you guidance. And there's 2 versions of Trusted Advisor. There's the basic and developer support plans, which get access to 6 security checks and 50 service limit checks. And then there's also, for the customers, some business support plans or enterprise support plans. They get 150 Trusted Advisor checks, 14 of which are related to cost optimization, 17 security, 24 related to fault tolerance, 10 related to performance, and 50 related to service limits. Let's talk about Compute Optimizer. Compute Optimizer is a free management tool that recommends AWS resources to increase efficiency and reduce user costs. Compute Optimizer reviews previous resource activity to distinguish use patterns. Compute Optimizer is going to compare your user's activity to similar activities on suggested resource, and then it will take the comparison and present the information to you. People using Compute Optimizer are given the option to look back to review 3 months of long-term data storage. This service is going to enable users to utilize resources that reduce costs and improve performance. Then there is the AWS well-architected tool. I wouldn't be using this at all. I would have real architects to know how to do things, but it's a free cloud service to provide guidelines and best practices for doing things the way AWS wants you to do so, including whatever locks you in to the things that are most profitable for them, or make it best practice to their service. So kind of keep that in the back of your mind. So it's going to help users theoretically plan and create better workloads to monitor and improve their existing workloads by getting advice and recommendations from the AWS well-architected framework pillars. It's used to define your workload of priorities and whatever trade-offs they feel you're going to get via security, performance, and cost. Okay, let's talk building high availability systems. Now, the advice to build high availability systems is never to use a single cloud. I'm going to say it again. High availability means no single points of failure. The military has an adage, 2 is 1, 1 is none. Single cloud, single point of failure. So, I'm going to say that right now. Now, I'm going to give you the AWS answer on how to build a high availability network, which is not the way you would do it in reality, because it's a single cloud. The way AWS talks about CloudFront being your content delivery network, and we've proved to you that they don't even use it themselves, they use multiple. Same reason you can't design high availability on a single cloud. It's a single point of failure, no matter how many regions availability zones use. So when you're building and talking about availability, you're talking about the systems being available or ready for you when you need it. You know, and let's talk about it. You know, if you pick up your phone and you dial it, your home phone, you expect it to work. If you go to a website to view photos from my beautiful cat Cindy, and you miss my Cindy's photos, you don't get that frustrated. You just don't. So the business requirements determine your availability. In healthcare, we got all our information on a single cloud. The cloud goes down and doctors and nurses can't find information on their patients. People die. You think that's okay? No. You go to dial 911 in the US for an emergency or 999 in the UK to have police show up, and they don't show up. Somebody dies. Not acceptable. You got a business that sells shoes at the village in Palm Beach Gardens, Florida. The systems go down, nobody dies. So their availability needs are different than a hospital's. So we must design based upon our availability needs. And our availability needs are going to be based on 99%, 99.9%, which is called 3 nines, 99.99%, which is called 4 nines, and 99.5 and 99.99%. So to put it into context, 99.99%, which is what AWS considers to be high availability, is 52 minutes of downtime per year. 52 minutes in a downtime per year in a hospital means somebody's going to die or could die. 52 minutes of downtime for an ordinary business is excellent. So again, business requirements drive your tech solutions. Most people are good with 4 nines availability, but not everybody. When you design a high availability system, there's several things that need to occur. No single points of failure, which means power failure, which is why when you design a high availability data center, you have 2 power companies in most cases, 2 sets of transformers, generators, and backup generators, because when the power goes down, it's out. So far in 25 years, the only company that I've ever seen that actually had a data center power failure was Amazon, which miraculously, the power failure in the US took down half the globe. I don't know how that happened. Keep that in mind. So in a data center, including AWS data centers, they must have redundant power. They must have redundant air conditioners. Why? An air conditioner goes down, the whole system goes down. No network. They must have multiple network connections. Do you think I can have 2 connections on AT&T? Of course not. No. I need to use multiple internet service providers. And we've done this for 30 years. Why? 2 links on AT&T, and AT&T is an incredible service provider. AT&T has an outage, we lose both links. AT&T and Verizon, AT&T and NTT, Vodafone and Orange. 2, doesn't matter. Maybe 3. Routers. We can't use a simple router where it's going to fail. We need redundant routers. And routers with multiple power supplies and all kinds of redundancy. Same thing for our switches. Same thing for our servers. We can't just have 1 server. We need more than 1. And the server should be plugged into multiple outlets on multiple circuit breakers. Load balancers reduce single points of failure. DNS. Good quality DNS. You got a DNS server in 3 different clouds. Cloud 1 goes down, you still have DNS to route your traffic to the rest of the cloud. Storage, got to be redundant. Applications need to be redundant. No single points of failure anywhere. None whatsoever. So AWS will tell you they have redundant power. Of course, they had a global outage. They'll tell you they have redundant cooling. Most likely they do. They'll tell you they have redundant connections to the internet, and I'm sure they do, because if they didn't have redundant connections to the internet, their business would be going down each day and they'd be losing lots of money, and they wouldn't let that happen. Redundant routers and switches, I'm sure they do. And it is easier if you don't know what you're doing to basically go to AWS and stick your environment into 2 availability zones, and then it would be to try and build a high availability system on your own. And AWS is banking on that for the people that don't know how to design for high availability. A bank knows what high availability is. So according to AWS, best practice is to use multiple availability zones, multiple data centers. And if you need greater than 99.99%, use 2 regions and 2 data centers until the AWS cloud goes down and you got nothing, which my grandmother would call bupkis. Again, you're down. Wouldn't do that ever. So anything that needs availability should at minimum be in multiple availability zones or data centers. That means virtual machines, databases. Kind of keep that back in mind. Now, if you're only going to use the cloud, you're going to need 2 connections to the cloud. If this is a 10 gig link and this is a 10 gig link, you might need a primary direct connection and a backup direct connection and a VPN backup for all 3. Some organizations might need 100 gigs on one link and 100 gigs on a backup link. And if you don't get the routing right, that's not going to work either. Can you have these 2 links on the same service provider? No, because now you got an AT&T link and an AT&T link on the way to AWS. AT&T goes down, and now you can't access AWS. Again, no good. So we're talking serious redundancy that we need to have. So realistically speaking, if you're going to stick all your eggs in one basket, which I wouldn't do, but it was single cloud, but even if I used a single cloud, I'd still be doing this. So as you can see here, we got 1 direct connection, which goes to 1 direct location, another direct connection through another direct connection location. And that way a direct connection location can fail, and our router can fail, and our link can fail in either case. And we're in much better connectivity. Now, I want you guys to think about security. If you get hacked, are your systems available? No. So, for your identity and access management, which is the least important and the last line of defense compared to all the other stuff, use the principle of least privilege. On your servers, disable unnecessary services. Patch your systems with security updates. Limit your VPCs and use VPC peering, or if you're not good with networking, and if you're not good with networking, don't design architecture in the first place, you can limit the blast radius of things using AWS organizations as well. Use access control lists and security groups, but also use next generation firewalls. Use physical security, meaning don't let anybody plug into your systems. If they do, use strong passwords. Use a second cloud while we're at it, and template any good configuration that you have with Terraform or CloudFormation, and that way you can relaunch things should systems get bad. When it comes to high availability backup, now if you back up to the same cloud and the cloud has a problem, you got nothing. So I know AWS will talk about backing up to another region, so don't do that. If you're going to back up to a different cloud, at least for disaster recovery purposes. But at least on this cloud and another cloud, create production images of your servers so you can use them and back up your data on a routine basis, however long it can be. Leverage auto-scaling because you can add performance as needed. Decouple your application architectures because if your database fails and your stuff is stuck in a message queue on the way to a database, you still got something. Use caching. Use redundancy in your DNS to route between cloud providers. Use load balancers to eliminate single points of failure. Part of running a high availability system, in addition to change management, is using logging and auditing functions to see what was going on, monitoring for systems alerts, monitoring security breaches, and monitoring for performance. So when it comes to this, change management is critical. Prior to making a change, somebody needs to tell everybody else that they're making a change. And all stakeholders have to agree with it because you change one thing in one place and it can change things in lots of places. Couple pieces of guidance on passing at the exam. The AWS exams can actually be somewhat challenging, but not because they're hard, because of the way they ask the questions. It can be ridiculous. I will tell you, it'll take you 10 times longer to figure out what they're actually asking in the questions than it will actually be to understand what they're doing. They're very wordy, and the way they ask questions are going to be challenging if you know something about tech. Now, if you don't know a lot, it's going to be a lot easier for you, and here's the reason why. When they ask a question, one will be the Cisco way, one will be the IBM way, one will be the AWS way, and one will be the Google way. And you're going to look at it, and if you don't know anything, it's simple. You're just going to know the AWS way. But if you've got real knowledge in you, you're going to struggle to figure out what they're really looking for. So here's my guidance. In addition to this course, read the book and look at those diagrams carefully. What is a white paper? A white paper is a marketing paper written by a company to get you to buy their stuff. Why do companies create certifications? It's a brainwashing way to get you to sell their stuff or use their stuff. So read their white papers. You see a lot of the questions from the white papers. Get yourself a practice test. Practice test is a great way to assess your understanding of the way AWS answers their questions and your knowledge of the AWS stuff. I'm calling it stuff for a reason. Keep taking one of these practice exams, like the kind from Andrew Brown, or Review and Prep. Again, I get nothing out of this. I'm just giving you exams that I found to be good, honest and ethical exams, and use them. And until you can get it, don't take the exam until you can score a 95%. Although temporarily, AWS really lowered their standards on these exams. And by what I mean by that is they enable you to take it and fail, and then retake it after you've seen the exam for free. They're trying to increase the number of certified people out there by doing so. Lowers the standards, increases the number of certified people, and it makes the certification less and less valuable. So train for your career and not just a certification. Career training and certification are different. We provide career training at our organization. But please do that. Now, the day before the exam, this is important. Because of the way these exam questions are written, get a good night's sleep. You're going to need it to read the way these questions are written. They are not written in a precision manner. Eat healthy, maybe work out the day before. I recommend you don't drink or do anything else the night before, because it's going to, if you wake up foggy and not at your sharpest self, they're not going to help you. Arrive early for the exam. I don't care if it's an online exam or an in-person exam. I took an exam and my Mac froze. I've shown up for exams, the power went out. Just Murphy's Law. Whatever can go wrong will go wrong. So give yourself ahead of time. Park in a good parking spot if you go to a physical center, even if you have to pay for it. On your computer, show up a half an hour, but be early. And that way, you're not stressed. Don't forget to have a valid photo ID for the exam. So let's take some questions. Wilson, if EBS is like traditional disk storage and EC2 is a virtual machine, well, EBS is not like traditional disk storage. EBS is block storage, which means it's network storage that feels like traditional storage. With RDS, AWS will spin up the required EC2 instances and attach block storage to it. Yes, absolutely. All virtual machines in the cloud use block storage. Your question is RDS and EBS the same thing? No. EBS is elastic block storage, which is a storage area network, which is block storage. A relational database management system is a relational database. So no, they're not even related to each other. But anytime you have a server in any cloud, you're going to have the server. And because we can't put a physical hard drive in them, because you can't use it because it's ephemeral storage, you're going to have to attach the block storage. So same thing on Azure. You're going to have an Azure virtual machine and you're going to have an Azure managed disk. On AWS, you're going to have an EC2 instance of virtual machine and a managed disk. On Google, you have a compute engine instance with their block storage, same thing. So Sarah, does AWS as a resource to support other cloud platforms? No, AWS tries to give you everything to make it harder for you to go to other cloud platforms, and all the other cloud providers do the same. Does AWS have a FinOps bug? So sorry, FinOps is the wrong thing. Here's what FinOps is. I messed up on my design and it's costing too much, so now I need FinOps to fix it. No. Your architects need the right business acumen. There were some architects that got early on that didn't know architecture, they didn't know business, and they didn't know digital transformation. So what happened is they made a bunch of stupid mistakes. They stuck the wrong stuff in the cloud. Businesses found their cloud costs went so high, and now they're trying to hire operations people that know a little bit about finance to go fix something. It's not the solution. The solution is you design it right in the first place. So you got two choices. You can prevent a heart attack or treat it. FinOps is after the person's in the hospital and they're ready to be dead. You're trying to treat it. Architecture is preventing the misproblem in the first place. So there are books on FinOps. FinOps, questionable. Real business acumen and real business knowledge, like we teach in our Cloud Architect Career Development Program, keeps you from making big mistakes. It's dealing with the problems from bad architecture. What's the difference between load balancing and auto-scaling? Load balancers, you got 4 servers, and you send it to some traffic to server 1, server 2, server 3, and server 4. Auto-scaling is you got 1 server and it's not enough, so you add a second server. Anthony, we're so happy to do this, and thanks for coming here this week. So happy to see you here. Rosa? Steve C., I'm thrilled to see you here. And thank you. Igor, do I recommend the associate first and skip and go to the pro? It depends on you. When I did the Google one, I just did the pro because it just did. I didn't want to waste my time with doing a beginner one, but I've been in tech forever. And, to me, when you know the technology, it's only a couple of days preparation for the exam. But if I didn't know the underlying technology, realistically speaking, I would probably do the associate first and then the professional. Does the AWS certification text have a hand-on section? Minimal. There may be 1 or 2 questions or 3 questions where you got to configure something, but it's a concept multiple choice test. It's a multiple choice test. That's all it is. FinOps is part of the CCOE, but, what is the right way to do it? The right way to do it is design it right in the first place. You can design something properly and it doesn't need to be repaired, or you can repair it because you messed up. So if it's properly designed, FinOps becomes much less and less and less relevant than it would be if it's done design. And I'm not saying you don't need FinOps. I'm saying FinOps is the way it's being used is being used as a substitute for bad architecture. You mentioned, but why would someone use a classic load balancer and a gateway load balancer? So classic load balancers, they don't want you to use anymore. It's the same thing as we all need. And a gateway load balancer is basically a network load balancer that's optimized to go to firewalls or network devices. Why would I use a network load balancer and not a gateway load balancer? Well, for the most part, there's no data on how gateway load balancers perform on the AWS website. The information is very cryptic, and organizations have been using network load balancers to load balance between firewalls for decades. So I'm going to stick with the standard technology that's known and been proven. AWS organizations as their means of hierarchy because they're basically trying to do things. But separating your VPCs is much more separation than IAM. I like to look at IAM as the last line of defense. So here, let's say here's what IAM is. Let's go back to our castle. We got our firewall, right? Which is a 300-foot wall around the castle. Then we got the moat, which is this water thing that's filled with sharks. Behind the moat, we got a bunch of Navy SEALs that are armed with M4s. And we got some people that have, say, a 243 Bravo to take out anything bad that comes in. Now, that is hierarchy. Now, if somebody beats the firewall they breach the moat and they get past our SEAL platoon, then they knock on the door and they say, my name is Mike Gibb. That's IAM. And organizations is more of an IAM-based approach. I'd say segregate it completely and not only use IAM, but use networking. But, you know, if you're not good with networking, organizations is a great way to do it. And with anything else, Ken, it's a combination of multiple things to add there. But the networking gives you great security. Pradeep, Mike, you're always awesome. Thank you so much. Love to watch your videos. Oh, thank you for doing this. I want to help any way I can. Bo, you do not need to be certified to take any of our courses, not whatsoever. If you are certified, we will have to teach you to unlearn many of the certification things so we can teach you reality. We work with people like Daniel Boso. I use him as the example. I've got hundreds of examples that have no background, but he's 20 and didn't even graduate high school, and we got him a job as a cloud architect. We love working with people with no background and background. Yes, I drink a lot of water, Ken. I really do like my water. I've got actually water bottles, water dispensing systems in 2 rooms in my house. Please, is AWS a good source to use in preparing for the exam? Catherine, I gave you the 2 sources that I find that are actually out there that are decent, honest, and respectable, which was Andrew Brown's Exam Pro and Review and Prep. I don't recommend any others. Greg, we're so thrilled to have you here. We are done as far as Sarah's last question. We have graduates from our program working in America, Canada, South America, Africa, Australia, New Zealand, Asia, the UK, and all over Europe, as well as India and Pakistan. Thank you all so much. It's been wonderful, wonderful, wonderful spending the week with you. Please join us next week on the How to Get Your First Cloud Architect Job webinar. If you haven't joined us yet, we'll make sure you know how to get your first cloud architect job if that's what you're so inclined. On Monday, we'll be from 2 to 4 p.m. Eastern. We'll be answering career questions. If you want to be an architect versus an engineer, we'll tell you what you need to know. We train architects, but there's other people that want to do other careers, and we know how to help people get hired in other careers as well. And we don't want to see you waste your time. So there's that. And who knows? If you follow me on LinkedIn, I promise you, we're going to have a really good thing for you to read next week that's going to give you some serious information that you're actually going to need to help you build any kind of cloud architect or serious engineering career. One additional guide, and you can only do that by following me on LinkedIn, because that's how we're going to describe it. So thank you all. It's been a wonderful, wonderful, wonderful week with you. If you've not subscribed, please subscribe to the channel, hit the bell notification. If you can, give a like to the video, signals the algorithms. And please tell somebody who's not seen this that needs help to watch this boot camp. You know, it costs, literally speaking, almost as much as a car to put one of these things together. I've got 7 professionals working on it 100% of their time this week. Took months of preparation to be able to put this kind of content together for you, for all of you, completely free. So please help us share it with those in need. There's lots of people in the world that are in need of training, and that's why we do these things. So please help share the links to these videos, make a LinkedIn post, make a Twitter post, send an email to somebody so more people can get free help. Take care, everyone. Thank you so much, and I look forward to seeing you soon.